Group Builders Night virtual, and every Tuesday night we just get together and talk around the table for projects we're working on, questions we have, and whatever other things hit our fancy. Just a brief glance at the calendar. We still have this discount code thanks to Jesse, who spoke to us a few months back. In the 10th of July, we have called a flash mob, but we're going to, instead of a regular monthly meeting for DPRG, we'll go to the Seattle Robotics Robothon. They've also made available on the 17th, they're going to have a training session for FreeCAD for anyone interested. And then we're working, of course, towards the Outdoor Rover competition in late August, both a mix of in-person and virtual. So with that, we're going to go around the table, and I'm going to kick things off tonight with a minor update. As it turns out, while I've been recovering from surgery, I found something to do in the easy chair. I was asked to help a 10-year-old cousin in the 5th grade with something she wanted to call Carl Camp. So basically, she needs help with a really crazy, smart 10-year-old. And I decided to get him and his other cousin one of these. So we now have 3 of these Make Block MBots. Mm-hmm. And for $75 or $80, it comes with a LiPo battery and a Bluetooth module. And I'll have to, it's worth a talk at some point if you guys haven't seen them and if you're all interested. But I have to say, for what it is, they have done a phenomenal job on the ecosystem with the Scratch language. It is so straightforward to program. We were up and running in minutes using an app you can download on your phone. And when you graphically lay out the for loops and whatever, and you run them, it actually single steps through the code, and you can watch it single step in the IDE on your phone or browser or wherever.
Wow.
Or you can, as I figured out last night, you can actually get to the other tool they have, a little more advanced, and it'll transpile. So it'll take your block structure graphical language, and it'll show you Arduino code, and then you can flash the robot with the Arduino code.
Is that a Raspberry Pi on top, or?
No, it's basically an Arduino Uno.
Uh-huh.
Well, on a custom board. It's the same at Mega, and under the covers you can see it's compiling Arduino libraries.
Uh-huh.
But it just went together so smoothly, and they've done a really nice job of connectorizing everything and protecting it from, young prying hands. They have a whole bunch of extension kits.
What does it use for motors?
The cheapy little yellow ones, no encoders.
Oh, no encoders, yeah.
But as I was shopping for these, I noticed they offer, it's totally out of stock, but instead of like $70, $80 for this, you can spend $100 or $120, and they have a Mega-based Mecanum wheel robot.
Mm-hmm. So you can get those cheapy yellow motors with encoders.
Oh, I'm sure of it, yeah. But this was all about right. What can somebody that's going to be in a sling for a while, what can he do to add value to a couple of 10-year-olds? And that's not involving like changing the kit at all.
Right. Well, and $70 is a good price for all that hardware.
I mean, for what you get, it's really, pretty reasonable. So for someone wanting to get started that doesn't want to mess with the mechatronics, doesn't even know software, I tell you, after we spent an hour and a half to assemble them, and within 30 minutes later of downloading the app, the one 10-year-old was already figured out the 3 programs on here that it came pre-built in, and he was 3 or 4 sections into the tutorial. And each tutorial, it basically teaches you one command, like do this and it blinks the light, do this and it moves the motor, do this and you can iterate. It is really well laid out to get people started in a hurry.
And they probably have accessories like you can put a clog on it or stuff like that.
Oh, they have 3 or 4, even for this one, which I guess is an older one. They have servo kit, lighting kit, a speaker kit. They have a crawling robot thing. You can put legs on it and it will crawl.
Do they have a pen plotter?
I didn't see a pen plotter, but they got these RJ45 jacks or whatever, and there's a bunch of, I mean, not only modules by the make block company, but there's third-party modules as well. And I haven't gotten this far yet, but it looks like they have a section on, so you want to be a developer. So I'm really tempted, if it goes that way, to figure out, okay, why don't I make a library for my little cousins so that they can drive a NeoPixel ring instead of just the single at a time NeoPixels? Why not?
Yeah.
Because it looks, if it's as straightforward as everything else is, I mean, once you get past installing the driver from China, I mean, it's really, really nicely done.
Oh, good. Does it look like they have extended shafts on the back of the motor? Could you stick an encoder on it?
Well, you probably change them out to get.
I'm sure you can change it out, and I don't see an extended shaft. And anyhow, this is an Uno, right? How much encoding you're going to do with an Uno?
Yep.
Yeah.
And I don't want to. I mean, I really want it to be plug and play, so I don't want to have to go digging in there to tap wires in.
Right. Yeah.
But I think these plug and play things, I think they're I2C, so you could get I2C extender and.
Do they claim compatibility with VEX? Because isn't that what VEX uses? A bunch of I2C.
Got me. I don't know.
Connectors.
Then I'm sure it comes down to the library, but
yeah.
But that's the advanced total of what I've been doing.
Maybe we should get into that business, huh? Make a kid-friendly robot kit. Could be next year's project, you know.
Oh, God. We already got started on a telepresence thing, right?
Yeah, we're almost done with that.
Almost done with that, and we got an outdoor competition facing us. So how many more distractions do we need? Okay. Well, anyhow, that's what I got. So who else would like to talk through an update?
Let's see.
I have a real quick one, but go ahead, Ted.
Okay. Let's see. I have an update. I've got my PID loops running reasonably well, and I was actually made it drive to a waypoint and back again. Let's see if I can remember how to do the. Where is the? Oh, there's the button. All right, a window. Sure, I'll pick a window. All right, so this was done with all just wheel encoders and gyroscopes. And let's see, I just set up some cones, had it drive 20 feet forward, I think, turn around and come back. And it did surprisingly well. I tuned the steering indoors on a wood floor, so it was a lot smoother. And when I went outside, the tuning kind of fell apart, so I need to work on that. But yeah, here's it going. I set up those cones at 20 feet. It drove right to them and turned around and came back. There's a lot of weaving, but like I said, I think that's just the tuning. So I'm happy with that. I was kind of wondering if stop sharing.
This is a powerful gaming computer.
Oops. Hey, stop. Hold on. I have YouTube going. There we go. Okay. Yeah.
Cramming a video down our throats.
Yeah. I was wondering if anyone had any experience with this. The way I did the steering and the distance, for that matter, is I first wrote some PID loops to control the linear velocity and the and the rotational velocity. I think I talked about that some last week and finally got that figured out. And then I wrote another 2 PID loops on top of those that, so like I want to drive to 20 feet, I had that PID loop control the velocity, and then to get it to the right waypoint coordinates, I had another PID loop controlling the steering. And it seemed like, I don't know, it seemed like that made it kind of hard to tune. And I might try just tuning like the steering without trying to tune it. So I had the steering tuning controlling the rotational velocity, and I might just try controlling the heading directly and see if I get a little better performance. It seemed a little laggy, but I was just wondering if anyone else had any experience with that.
I had a question about the weaving. Did it start out in kind of like a damped oscillation? Did it, get less and less the further it went? Or?
Yeah, and so that might just be the tuning. When I originally tuned it indoors on a wooden floor, and it worked great. But it was when I went outside onto the lawn that it kind of fell apart. So it might just be a matter of tuning it differently for a flat surface and a bumpy, grassy surface.
Yeah.
So you have an inner loop and an outer loop, is that right?
Yeah, well, I have basically two PID loops, and the outer loop is controlling the, like for the linear velocity, I have the one PID loop that tries to maintain a velocity, and then the outer PID loop tells it what velocity to maintain. So as it gets closer to the waypoint, it slows down until it stops at the waypoint.
But why do you need a PID loop for the outer loop?
Yeah,
right? I mean, it's not clear to me. The inner loop, clear, right? You gotta compensate for the uneven surface, battery voltage fluctuation, all of that. That's what you need the inner loop for. But if the outer loop is just setting the target speed, I'm not sure. I mean, I'm not sure you want a PID loop there that keeps kind of changing that target all the time. According to what is it changing?
Well, so for the speed, yeah, I kind of see what you're saying. But the idea was as it got closer to the waypoint, it would slow it down. So the error was the distance from the waypoint. And when you get to the waypoint, you want it to stop.
Okay.
Yeah, Ted, I've actually done something relatively similar. I mean, and I kind of called it a behavior. I think I've described it before that I've got an infrared sensor, an analog infrared aiming forward on my robot, and I've got what I call a roaming behavior where if the analog doesn't return any value, in other words, it sees to infinity, it runs the robot at full speed, and then as it gets closer to something, it slows it down until it gets to 20 centimeters and then stops. And that's basically a behavior. And the motor controllers have got PID loops, but the controller for that behavior is not a PID controller. It's a higher level behavior. And I think David Anderson would say the same thing, that that's a higher level behavior and shouldn't be in a PID.
Yeah. And maybe that's a good point. Now, the heading seemed like that needed something more like a PID loop, trying to, I want it to turn quickly to the heading, but then slow down and not overshoot. So even though that's it, what I ended up getting as soon as I went outside, it would ramp up and then it would overshoot and then it would come back and oscillate.
So
Is this in Python or C?
This is C.
Yeah.
See, I'm still saying I don't think you need or want a PID loop to accomplish what you're trying to accomplish, because I think you're making your life harder because you're going to get into that oscillation. I think you can probably just have a very simple logic that slows down as you get closer, but without all the feedback and the risk of oscillation that you get with a PID, right? You don't need that sophistication of a PID loop there. It can get you into trouble there, I think.
Yeah, Ted, all I'm basically doing with my roam behavior is that the PID, both my left and right PID controllers have got a target velocity, and that's then abstracted. So I don't think about that. I just know the PID controllers are doing their job. And then my roaming behavior or any of these higher level behaviors are just setting the target velocity of the PID. but the actual velocity that you want for a particular moment of the robot's performance is set by some behavior, a higher level process. And so as I get closer to, as you get closer to your target or I get closer to my wall, I'm just setting the target velocity and letting the PID controllers do their thing. But I don't have a feedback loop in that. The behavior, the high level behavior, is setting a target velocity and just assuming the PID loops are taking care of that, for me.
Yeah, that makes sense. I think you guys are right. I was overcomplicating things.
I don't know. I'll play devil's advocate here. So at least on the mechanical wheel robot that I have, so there is an independent velocity PID loop for each motor.
Right.
And that each so I set the velocity command for each motor, and the PID loop for each motor sets the velocity of that motor.
Right.
And then outside of that, I'm at a higher level, you would say, I guess, it mixes together whatever the commands are for translating left, right, front to back, or rotating. So I mix those together into whatever the corresponding wheel velocity should be. And then what I do have is actually a PID loop on the heading.
Yes.
So it
Yes.
closes that outer PID loop. It has to be, you look at poles and zeros, it has to be a much slower loop than the motors, right? 3 to 10 times or whatever, slower response. But that outer PID loop then, it closes the error around the absolute heading in my case. So
Yeah.
I set literally a number of degrees in that outer PID loop. Then if it's far away, it slews quickly. But as it gets close into the correct heading, it slows. It has less of an effect on the rotation.
Right.
Now
And
that's a really straightforward thing in a way to me for the cannon wheel robots, because it can turn without moving forward. But I guess yours can too. You can
Yeah,
turn
correct.
without moving. So I would expect that the same thing could work in your case. But I would guess that it needs to have some modifications if it's going to be like Ackerman steering, because then if it's not moving forward, then you might wind up slewing the wheels. Even a gradual one will ramp up over time. And
yeah, basically,
the wheels way
I agree with
sharp.
with what's being said, Ted.
Yeah,
Essentially,
it's got differential, right, Ted? You've
Yeah.
got differential.
Yeah.
Yeah, correct.
Yeah.
This robot has differential, so it is pretty much the same thing. And I've done this with Ackerman steering robots before. The key there is just make sure you're not running the PID loop when you don't have any forward velocity. And then I think, in reverse, I think I had a different PID loop for reverse because the tuning's different.
Ted, so I think summarizing what they're suggesting.
And Doug, you're muted right now.
Oh,
Doug P.
okay. What I think everybody's saying, and I agree with the general thing. If you think about it, your feedback loop has got a reference and a feedback. All right. In your case, so when you want to do a slew or whatever, like in Murray's talking about an upper thing, all you're really doing is changing your reference. Okay, and the feedback is handling the speed. So whatever that reference changes, that now you need an outer loop, but it can come into the same node. Okay, and that's your heading, which is what Carl was talking about. All right, and it doesn't have to be real super fancy, like Carl was talking about degrees. You remember, because what you're basically running there in most cases is just a proportional controller. You might not think of it as a proportional controller, but if you think about it, the higher the number of degrees is, the more it turns, right? The lower, when it gets down to 0, it stops turning. That's a proportional. It's just got a K of 1. Okay? And if you don't like the way it's responding, you can multiply it by, some coefficient to change that response. So like I said, you have to have 2 PID loops, one for heading and one for speed. But the outside one is so simple, it can simply be the value of the heading error. And then, like I say, you multiply it by some coefficient, and that's equivalent to a proportional controller. So, anyway, you don't, yeah. So when you want to make changes in your speed, either by slewing or whatever, just use it by changing your reference.
So,
Let me ask this question. Pretty much, I think you and I control our robots in a similar way. We have velocity PID loops, and if you're trying to get to a certain distance or a waypoint, that you're using that velocity PID loop to keep your motors running at the same speed. But when you get closer to your target, you slow down, and because if you don't slow down, typically you're going to overshoot. You just can't stop instantly. Same thing with turning. I think you do the same thing I do. We turn at a certain velocity, and it has to be pretty slow, because again, if you're trying to get it to a, down to like a degree of angular resolution when you turn, if you're going too fast, you're going to overshoot.
Right.
Yeah.
So, you can, as you get closer to that waypoint, you can, certainly slow it down and achieve better accuracy. But I think that's what you do, right? As well.
Yeah, exactly.
Yeah. Oh, okay. Oh, I meant Doug P.
Oh,
Sorry.
yeah. So controlling otherwise, if you know what your waypoint is, all right, you've put in a waypoint, and you know where you are, okay, because you've followed your odometry, you can tell the distance from your waypoint. All right, even without any sensors, okay, it says I'm 5 feet away from my waypoint. Well, then you can start initiating your deacceleration slew, okay, and get close to it. Now, if you're like in the, say, Robo Columbus, there's only one waypoint that's really important, and that's the one at the cone. Do you know what I'm saying? So like if you took 2 waypoints and then went to the cone, which you could do, the other ones you can just kind of drive through them. You just need to get to them and keep going. But the last one, you definitely need to be slowing down, and so it's easier to just do it for all of them. You know what I'm saying? But in the last one, you're going to have the benefit of having a target. I mean, a cone. So now, not only do you know your distance to the target, because you might not actually want to put your waypoint right on the cone. You know what I mean? You might want to put it, say, 5 feet away from the cone. So now you can use your camera and whatnot to drive to the cone with your camera and a blob detector. So I don't know if that helps.
Yeah, that's kind of my plan of how to do it.
Yeah. Now, a couple of things that are kind of thing to remember from David's talk. Like when you want to turn, if you want to turn like a pivot, which you can do because you've got a differential robot, all you have to do is make your forward velocity 0, and then you'll rotate in place. If you don't do that, then you'll do some sort of sweeping curve depending on what your settings are.
Right, and fortunately, my motor drivers do the mixing for me, so I can just tell it linear velocity and a rotational.
Mm-hmm. Yeah. Now, like if you're doing your heading arrow loop, you shouldn't. When you approach your target, you should be pretty close. You're almost 0. So what happens is when you get to your target, now the heading error is going to change to from a 0 to a big number. All right. So at that point, if you're turning in place, you just, like I said, set the forward velocity in 0 until your heading gets within some sort of tolerance, and it'll just turn. All right.
Yeah.
Or you can say, let's say it's an intermediate waypoint, you don't really want to stop. You could just keep on right. It'll do this big sweeping curve. In fact, that's a lot of fun. You know, by changing different speeds, you can get all, you know, a whole series of curves, and you find the one you like, you know.
Yeah, it's kind of funny. I did notice that sometimes it would like stop 6 inches maybe to the left of the waypoint, and then it would swing 90 degrees to point at it.
Yeah. I got something. Since I'm here, I wanted to talk about my 4071 Pololu sensor some more.
Oh, cool.
Okay, I managed to get it where the 3 are now running on pin change interrupts. It's really cool. The problem that you have with these guys, and I'm going to have to do this. Let me see. So let's say this is your first sensor and it pulses. It goes some distance and then it pulses down. Well, if you have a second sensor and it's coming around, it does it at some random time. And between the pulses is 8 to 9 milliseconds. And so if you trigger on one pulse, you'll see the other pulses changing depending on where they happen to fall. So you're essentially getting one pulse every 10 milliseconds, okay? And you want to be, and the 3 of them are totally asynchronous. You know, you don't know when they're going to occur. They're just going to occur sometime. So the pin change interrupt seems to be handling that really, really well. Now, it is
A
possible.
single interrupt or 3 separate interrupt pins?
It's 3 interrupt, 1 interrupt. Each of the outputs are a single interrupt pin, okay? But they're only 1 interrupt.
Right. Yeah,
So
I'm familiar with
I
that.
have them
Yeah,
all.
one handle.
Yeah, I'm having them all on the same port, and it's working really well. And I'd like to share. I'll share a link that I'm going to put in the chat. That is an absolute must read if you want to understand how to work with these pin change interrupts. It talks about all of the problems that you're going to have with any interrupt, like trying to send a long over from an interrupt to your program where it could change in mid-value and you wouldn't know about it, and all the other problems that you run into and how to not do that. And I'll put that link in there. It's really a good link. Now, remember I said, well, hey, they also have an enable pin, so maybe you could just like hit the enable pin and then capture the pulse, and then that way you could time the pulses when they occurred. Nope. What happens is when you hit the enable pin, it takes 60 milliseconds before the first pulse starts. So that's why they default to a continuous run. So you don't want to. You just want to let them run continuously. Yeah. Now, I did not, because our weather here hasn't really been that extreme. Like the people up north have been getting really bad weather. We've been having pretty decent weather, and we haven't had a lot of strong sunlight, or at least when I was testing robots. But I did take one outside this afternoon, which was during normal, probably less than 100 lux and K-lux, and just kind of normal outdoor, and they were picking up. If you move the cone, and I was doing it to a cone, if you move the cone in, as you got in within about a yard, they started randomly picking it up, but not consistently. And it was only when I got them up to 20 inches that they were pinging every time on a cone. Okay. Now, so like at 25 inches, they were probably pinging half the time. Okay, so you'd still be getting a signal, but you might want to have to do some averaging before you acted. But at 20, they were pinging solid. So now I just got to get out on one of our super Texas suns and see if that changes at all. So it looks like yes, 20-inch infrared sensor is not nothing to sneeze at, even outdoors. Even though, and indoors they get the full 130 centimeters or 50 whatever inches that is. I mean, they do that without any problem. And I do like the 15-degree setup. I'm probably, that you saw earlier, probably going to continue with that. You notice that I put them horizontally. Now, I didn't do a lot of testing, but I did do some testing with them with vertical and with horizontal, and I got better results with the horizontal. Okay. Results may vary. That was just the little testing that I did. Let's see what else I wanted to tell you about them. I told you about the... Okay, so anyway, I'll put that link in there, and like I said, if you're not aware of all of the problems you can fall into with an interrupt, I would definitely suggest reading this article. And I think that's all I wanted to say.
So did you get out your? I think Dave has one. The Kodak Grayscale. It's like a great card.
No.
It's kind of a reference.
Yeah, I'm still a little worried about. I mean, I know it can be done because I've seen Dave do it. I've seen Scott do it. And they both use. Scott uses a Pixie 1, and Dave uses a previous generation chip. I did say one thing. My driveway slopes down like this, okay? So I stuck my robot on it, and it really shows the benefit of what David was talking about, having it angle, because even though the slope on my driveway isn't that extreme, I could see where I was running into problems. So, you know, you would, otherwise I was picking up the ground some of the time. Once I put a board under the front and made it level, those problems disappeared. So, definitely, I was a little surprised. I don't know why I was. I mean, it makes sense, but I just was a little surprised at how big an impact it had on such a small slope. Okay, but when I guess the longer you're looking out front, the more the problem's going to hit you. You know, so if you're only at 20 inches, it probably isn't a big problem. But if you're looking out at a yard or so, it gets a bigger problem. Okay. And I'm hoping next week that I will be showing a robot running around on the ground. So we'll see how that goes.
Cool. All right, I'll go next. Yeah, so getting back into playing and exercising the LiDAR on my Romy, and this is that RP LiDAR A1 that I've been using. You know, it's like $100 LiDAR. You know, similar in performance to what you find on the, you know, Nido robot vacuums, and you know, I got a couple used one of those too from eBay, just the LiDAR unit. So that's what I've been using in the past and recently, and you know, I probably mentioned before, sort of, let me just share. It's a quick recap. I mentioned before that with this low cost LiDAR that's, can you see that? Because I'm not really 100% sure. You able to see that?
Yeah.
Okay. Because it's, yeah, I'm using my Linux laptop, and it's the user interface is a little different. So you know, when I mentioned before, I mean, if the robot's standing still, okay, you get a good, nice scan there. Everything looks really good, but you start moving, especially when you rotate. And this kind of an extreme case that I was for testing, you kind of get a totally distorted view, right? Because, well, the LiDAR is slow, and the A1. You know, nominally they tell you, 5.5 hertz. You can easily get to 7 hertz. You go beyond that, it gets pretty pretty shaky, sort of, it starts to vibrate quite a bit. So 7 hertz is sort of practical with that thing. And again, so you rotate, you're going to get this distorted view, which becomes a problem for some of the logic, in the SLAM algorithms. They just seem to be struggling with it. I mentioned that I did a bunch of, math that gave me a lot of headache to kind of take the distortion out and do some motion compensation. And I'm really proud of myself for doing all that math. And it was a, very interesting academic exercise. The results were good, but not perfect. And so I was almost sort of getting back into that, trying to improve on that. When I on eBay, I came across, across a listing that looked promising. And, again, I mentioned before, one way out of this is to kind of just spend more money on the LiDAR. Well, there's only so much I'm willing to sort of spend on stuff before, it's just like guilt kicks in, right? So the next level up from the A1, next level up from this, the A2, retails brand new for $320, and they have more levels. You can go to 600. So the A2 retails for $320. But on eBay, I got a pair of them for $160.
Ooh. Wow.
All right. So I got a pair of them for $160.
Yeah.
I got lucky. It wasn't a buy it now auction. It was actual bidding taking place. I didn't have my hopes too high, right? Because people know what these things are worth. It's used. So I had to keep my fingers crossed. But I guess I got lucky. There weren't too many people interested. And so I ended up getting the pair for $160. All right. So on one hand, I only needed one and I had to buy 2. It's a bummer. But on the other hand, if you think about it, right, if I'm going to put this into a competition robot, let's say, you got to have spare parts, right? If I zap that thing, right, if I make a mistake and that thing conks out, then I'm dead in the water. So it's not a bad idea for those kind of critical parts, right, to have an extra one. Otherwise, you just potentially out of the race in the last minute. So I have 2 of them now, and I only got it yesterday, so I haven't really done a lot of comparison testing yet. But it's rated for 15 hertz update rate, but I crank it up to 20 hertz, and then that runs as smooth as butter. It's just mechanically so different. That thing at 20 hertz, you can barely feel that it's rotating. You can't feel the vibrations even when it's mounted to my, to my Romy. It's spinning at 20 hertz right now, and at the other one, when I was going beyond 7 hertz with the A1, my robot was starting to do this. But with this one, at 20 hertz, it's rock solid, and I'm really happy that it wasn't a scam and there aren't any issues. I don't hear any noises coming from the bearings or whatnot, right? These things are gonna at some point conk out, right? With these moving parts, but I don't see any obvious problems, so I'm real happy. I just got to figure out how to mount it, because it comes with this fairly bulky, fairly robust but bulky cable, and the USB to sort of serial adapter, and it's a bit bulky, for my Romy. It's running into some issues there, but that's, I think, so. I probably just gonna go directly into that JST connector, which I hopefully ordered the right one, and then I just need to produce the PWM signal myself, or just set the motor to always on at full speed, and have another way of USB to serial, which is straightforward. So I don't, this thing is it's a matter of convenience, but you don't really need their adapter and their cable. So I'll make my own little cable to cut back on, just the bulk And then we'll see how that goes and run some tests, and we'll see if that gives better results for some of the SLAM algorithms that don't like the distortion that much. So
to drive the thing. It's not doesn't drive itself. Doesn't have a little processor built in to control its speed.
So there is apparently a motor driver built into this, and you give it a PWM signal, right? And because, for convenience sake, you attach it to your computer over USB, right? This side is USB here.
Yep.
So there's actually a little STM. There's actually a little STM32F103 inside here. That's just, I'm guessing it's just passing on the serial signals, and it's producing the PWM, right? So somehow you tell it through their protocol, hey, I want to run it 50% whatnot, right? And then it's driving the PWM signal, which is just one of those pins there.
Yeah.
I mean, it's power ground, RX-TX, and then PWM. And so, as far as I know, you don't even need to PWM it. You just clamp it at high, and then it goes full tilt at all times.
Oh, okay.
So that's that way. I should be able to cut back on, on extra bulk, and again, I just need to make my own cable, and we'll see how that goes, and then run some tests. So, but I'm just real happy that I got that deal, because again, I wouldn't spend $320 on it. It's just not worth $320, right, a piece. But $80 a piece, yeah, I can live with that. So.
That's a really good deal,
The
Chris.
faster
I mean,
scan rate
fantastic.
Yeah, I mean, fastest scan rate.
gonna prevent that
It's doing more
distortion?
samples per second as well, but it's the fastest scan rate that I'm interested in. That I think is for me, at least in my experience, is what's important now. It's quite possible that the data gets. I noticed the data gets quite bouncy. I haven't done a side-by-side comparison to the old one. Maybe I'll mount them both and stack them right on top of one or the other. I don't know how well this is coming through now, but the things get a little bouncy, and I don't know if that's because they're just squeezing more out of this little thing, or for other reasons. But so I have to see if I'm losing out on precision and accuracy as a result of spinning it faster and so on. I don't know that yet.
Ooh.
Other than that, nothing else new. The other thing I was thinking of doing, again, inspired by David's talk, I was thinking of implementing sort of the bare bones, in its simplest form, right, as kind of taught by David, without any software frills around it. Implement, the subsumption logic in Python. I don't know if I'll get to it or not, but I was thinking of doing that, but keeping it deliberately, excruciatingly simple. That would be my goal, right? To not even take advantage of too many sort of fancy language features of Python. I don't even know how to use most of them anyway. But I was thinking of doing that, and just as a fun exercise. But again, a couple threads going on in parallel, and I don't know yet where I'm going to spend time.
Well, Chris, I think there's probably two ways to do it in Python. And one is to kind of, in a Python script, emulate what the C code or the assembly code in a non-Python system would do, and just have a simple loop that goes through.
Exactly.
And you could kind of take David's code and just re-implement it in Python.
Yeah.
And that would probably certainly be simpler. I've, of course, done the opposite, which is to make everything way more complicated than necessary. But I think that it probably, if you can avoid using threads or multiprocess or async IO, and you can get it to work, great. And I think I think you're right. The only way to do that possibly in Python is just keep it so dead ass simple that it can't be done any other way. And I think you'd probably be fine. As soon as you try to get into multi-threading or any kind of asynchronous behavior, or multi-core, parallel, anything like that in Python, you're just in for a world of pain.
Yeah.
Chris, what is Circuit Python?
Okay, so Circuit Python is a derivative of MicroPython, and both of them are really just two flavors of the same thing, which is Python designed to run on microcontrollers, right? Not on your laptop, not on your Raspberry Pi, but Python running on, something as low end as a Cortex M0 Plus, or your run-of-the-mill Cortex M3. Processor-wise, speed-wise, it's not so much an issue. You gotta have enough memory to sort of support Python, but that's what it's designed for your Cortex M3s and M4s and even M0s if you throw enough memory at it. And it's a subset. Not sure it's a subset of the language, but it's certainly a subset of the available libraries that you get, and so that's where the main issue comes in. I mean, apart from performance, right now you're running this on a microcontroller. As it is, Python is not nearly as fast as just raw C or C++. Now you're doing it on a microcontroller. You have to realize it's not going to be terribly fast, but what you're really giving up on a microcontroller environment is sort of the rich set of libraries that you get with regular Python, and that's kind of one of the claims to fame of Python, right? You get such a rich ecosystem of libraries. So you just have to be aware of that. But on the other hand, the kind of stuff you do with a microcontroller, the Adafruits and SparkFuns, right? They have everything available. Circuit Python is Adafruit's flavor of MicroPython, right? They decided that they wanted to make it. They decided they wanted to give people a slightly better user experience, or in their view, where that user experience of Circuit Python includes the moment you plug the thing in, you get a disk drive on your laptop. It shows up as a disk drive. You drop the code in there, you're done. Okay? So as far as the workflow goes, it's one of the things that I believe MicroPython doesn't do. And there's a couple other nuances like that where Adafruit just decided they're going to go in a slightly different direction to make it even easier for people. But you lose out on other things that MicroPython has that CircuitPython doesn't. But again, short answer is it's a stripped down Python for your microcontrollers, and it can be convenient again. And I mean, Murray has been talking about toying with the idea of porting his fairly sophisticated body of Python code to MicroPython. I don't think that would ever succeed, just because you don't have the full set of libraries available. But I find it really useful for doing, the kinds of things where Python is really useful. I find is when you want to do something interactive, right? You want to fiddle with some sensor, and you're not quite sure yet how to use it or how to integrate it, or what you want to tweak different parameters. So what Python is good at is this interactive mode of using Python. Now, when you do that on a little board like this, you've got your GPIO and you've got whatever connected to it. Now you can interactively, work with those sensors that you have connected. You pull in those libraries from Adafruit. You talk to, the IMU or whatever else you have connected, and you just kind of explore the different settings, maybe of the sensor, different operating modes, and it's a lot of convenient experimentation you can do in Python on a microcontroller, with sensors connected to it on I2C and whatnot. So that it's a very, very useful it's a use case that I find it's working very well for.
Basically,
go ahead.
The CircuitPython is effectively a proprietary Python, as Chris said, written by Adafruit, and they have modified the bootloader so that when a microcontroller with with that bootloader set up for CircuitPython first boots up, it has some files on there that just immediately start running, sort of like an Arduino. And so what they've done is designed a extremely small, lightweight Python that is designed for beginners, and it's for schools and things like that, and also for their product line. Whereas MicroPython comes out of the Python community, and it's a public process. And so it effectively looks, the MicroPython community is part of the Python community, subset of it, and they look into the CPython community for things they can pull out. And so there's, for example, a GitHub project called MicroPython lib, and that is a gradually increasing port of a substantial number of the Python libraries like async.io and stuff. And what they've done is they've gone with micro to U in front of a normal Python library. They'll be like upip and U. I don't think they've done NumPy yet and some of the bigger, more complicated libraries, but their MicroPython is gradually becoming a significant portion of Python. And so the thing I had started to interject with Chris was that in the implementation I've got on my CROS core, which is my subsequent smaller attempt at a core, I'm trying at this point to simply get it running. And then what I'm going to do is go back and see which of the libraries have been implemented in MicroPython lib, and hopefully be able to pull the whole thing across onto a RP2040, which is the Raspberry Pi RP2040, which is inside the Pico, and that one can run either C++ or MicroPython. And so a lot of these boards can run either C++ or MicroPython or CircuitPython. A few of them can run all three, and depending on your bootloader. And MicroPython is gradually, there's even an async.io, which is a really complicated, difficult library. There's async.io is now in MicroPython. So it is gradually building up a pool of Python tools that are starting to rival a substantial part of the CPython libraries. Nowhere near the thousands, but hundreds anyway. And so you will be able to run pretty complicated Python-ish code on a microcontroller, which is a huge thing in the last few years.
So Dave, let me ask you, why you're asking, you're interested in using Python for something? You have a use case in mind, or?
I was most curious as to your experience and what you found it valuable for. So that was a real good response.
Yeah, but I would say I would describe CircuitPython slightly differently. They actually branch off of MicroPython, so I wouldn't call it proprietary. They keep pulling MicroPython into CircuitPython, but the reality is, you both are very useful. They do certain things. One does certain things better than the other. So depending on the use case, you kind of have to look at, okay, what does MicroPython do? Do I need that feature, or do I need that other feature that CircuitPython has? But both of them can be really handy. Again, it's really, to me, rapid prototyping maybe is a good way to describe it, because of the way Python sort of emphasizes this whole ecosystem of libraries. It's just, you get a way of rapid prototyping that I don't think you really get with C or C++. Sure, there are libraries out there, but it's not the way libraries get integrated into C and C++ code, right? It's outside of environments like Arduino and Platform IO that have streamlined that, right? Unless you have that, but it's still not as convenient, I would say, as with with any sort of flavor of Python. So rapid prototyping, that's what it's great for, and even on a microcontroller. I was just gonna real quickly show. So I just plugged my thing in, and what I mentioned earlier, it shows up as a drive here. So this is my CircuitPython drive, and it's very small. Obviously, it's a small amount of flash, and then code.py is the is your main application. And again, like Murray said, you plug it in, it runs that Python script, that Python program, and different editors are designed for this environment, and you can use whatever editor you want, and you can just bit bang some IO and work with I2C real conveniently. So for that, I think it's real great. If you don't need the raw speed, if you need raw speed and you're better off with C and C++.
So, Chris, I've worked with Python. The only microcontroller is the OpenMV cam. Do you know if that's Circuit Python or what that is?
Do not know.
It's a version of MicroPython, I believe.
Okay, micro.
Yeah. I should also point out, Dave, if you want to try this out, the Raspberry Pi Pico board for $4 has MicroPython on it, and you can go to town and play with it.
Yeah, and you can do Circuit Python, right? So I'm kind of going back and forth because, again, one is good at some things, the other is good at some other thing. At the end of the day, it's all Python, just you get different libraries. Like MicroPython does threads, Circuit Python doesn't.
Right.
But then I think one of them was doing I2C slave, the other one wasn't able to do I2C slave, something like that, right? So you just kind of have to look at what you need. But yeah, I mean, Doug is right. I mean, these little, even Cortex M0 Plus, right, which is what that is, it'll run it at some speed, and it's not a fast speed.
When I said proprietary, I only meant that CircuitPython is being effectively owned and trademarked by Adafruit.
Right.
MicroPython is actually a public project. And that is the big difference, is that CircuitPython doesn't have any kind of parallelism at all, that it's a very small subset, whereas MicroPython is growing and has, I believe, I don't think it has threading, but it has multiprocessing and async IO, but it doesn't have threading yet. So I'm using async IO, and I haven't tried it yet, but I plan to use, that's one of the reasons why I started using async IO, is that it was implemented. Now, in terms of things like I2C master slave, that's been implemented depending on the hardware. And so STM32 and a few others, the Pi board, it's been implemented, but the rest of them, no. So like,
yeah, I found all of them have master. I mean, because just about every micro has I2C, but I forgot which one doesn't do I2C slave. One of the two flavors
only
doesn't
two
do the
do.
slave side.
Only two do, STM32 and the Pi board. And I'm banking that the RP2040 will eventually, only because there's so much, it's got so much momentum now, but it's not widely. And in fact, when I was chatting with Sion, who's the guy that does, he's Unexpected Maker, who makes the little tiny Pico board, he's actually done a PR for that and pushed it into the Python community, but he doesn't have any time because he's so busy selling product that it's probably going to be forever before the ESP32 gets it. In fact, I chatted with somebody who thinks the ESP32 might be just about impossible to do it, just because of the hardware. But the STM32, David, it certainly works on an STM32. So, yeah.
Hey, Chris, don't you find that, I mean, the number of libraries that are written in C, Adafruit may be the exception. Maybe they're doing, several MicroPython or CircuitPython libraries, but it's probably, I mean, if any device, if an Adafruit doesn't write a driver for it, you're probably going to have to create it yourself, like one for the...
Yeah, I mean, I think when it comes to sensors, like anything that attaches an I2C or SPI,
Yeah.
you're right. I mean, those libraries are readily available. You're totally right. I guess I was more thinking beyond that, like libraries that you might need for certain kinds of data processing, right? If you need to actually crunch some numbers, if you need to, work with more sophisticated data structures, I think Python gives you an environment where you just get more of that out of the box. To me, at least, it seems more readily accessible, right? You do pip install this library and boom, it's on your laptop and you go use it. And it's just very streamlined process, I find, right? I mean, again, beyond the devices, you're right about Adafruit making a lot of libraries available that are kind of Arduino, framework libraries. And with Platform IO, I have to say, I mean, it comes pretty close, and maybe it's equivalent to Python, because with Platform IO, right? Which is Arduino on steroids, I would say. You say you need this library, click, 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 done. So it's very, very convenient for a certain type of library, right? For interfacing with a particular type of widget. Those libraries are readily available in C and C++. But then again, other types of libraries, and maybe I don't have a good example right now, but that's where, that I don't think the ecosystem is as rich in C and C++ land, or it's you have to do a little bit more legwork to actually make use of the libraries that are there.
Yeah.
So
Yeah, I mean,
several years ago,
Every device.
I found these radio modules I used in a project. SparkFun sold them. They're made by Synapse, and they ran Python. And I found they were the same footprint as XBs, but they were very powerful because you could program them in Python. The only issue was it was a bit limiting, because if there was something that Python couldn't do, you just couldn't do it. And I think they had their own version of Python, and it was very limited in what it could do. So it sounds like these are a lot more powerful now, as far as having more libraries and more support. So
yeah, for sure. But I think you always, when you do something like Python on a microcontroller, you're gonna run into one limitation or the other, right? I mean, that's a given. It's just so much memory you have, and so much performance you have, and Python just wants a lot of it, and so there's only so much you can do.
I'll say one of the things that I'm seeing where I'm using MicroPython is that some of the camera boards that I've been messing with essentially have a limited version. I wouldn't say they have full OpenCV, but they have a limited version of OpenCV on their MicroPython libraries, which makes them pretty easy to use for vision work. So that's where I'm getting into it. I've got a couple of those Pi Picos that I'd like to give a shot just to play with, but not until August is over with. So since I'm talking, I got one other thing I wanted to tell everybody about. All right, for looking at sensors for my rover, I was looking for some sort of ultrasonic sensor. Now I can't get the ones that David has or these, but I found these. These are put by Seed with several E's.com, and I put the link in there. And okay, here's your standard HC-SOR4. Look similar, don't they? Well, there's a lot of problems with the SRO4. The first is that they're made by a gazillion different people, and the microprocessor that's on there is often different from manufacturer to manufacturer. And one of the biggest problems is when you ping with this guy, when you get your answer, okay, you might not be able to ping again for 30 or 40 milliseconds. And it's got some other, you can use the new ping library, that's an Arduino library, but the problem with that is what it says is after a certain amount of distance, I'm not carrying anymore, so I'm throwing out, I'm going to let you do something. Well, that sounds good, but you still got that sound out there, and you can run into trouble. This guy is substantially different in the sense that it's rock solid to 5 feet, actually 62 inches, but rock solid. Okay, it has a varying ping distance. So like if something is really close, it pings quick and repings. So you get a quick reading. And that pinging can be anywhere from 12 milliseconds up to 32 milliseconds. So if it's out there at 5 feet, it's going to be 32 milliseconds. And it uses 3 pins, very much like the. It has a Grove connector to it, but they also give you the wire to go with it, so it's not a big deal. And but they're similar to the Parallax Ping in that they really only use 3 pins. This is also the sensor that, remember a couple of weeks ago I told you about a person had hacked into it to actually get a analog magnitude of the signal. This is the sensor that would do that. That's what caught my eye. And they're about $4.50. And they come from a what I'd say a legitimate company, so that they're not going to be an eBay special where you might get a good one, you might get a bad one. You never know. And so I got 4 of them. They were all exactly the same.
And Doug from Seed Studio, yeah, I'm familiar with them as well. Do they sell multiple versions of that, or if I go to their site and do a search on an ultrasonic, I'll get that
I
one?
put the link in. The link's in the
okay.
chat.
Thank you.
Yeah, like I say, it's I'm going to probably chunk all of these guys and just start using this guy until I find something wrong with it. But right now, it's the best SHC-SR04 type sensor that I've seen. So another
How
little.
much was it again, Doug? How much was it?
I think it's about 450. I think.
That's great for the community, Doug. It's because there's so many crap ones out there. It's nice to find.
I mean, you go on eBay, it's just a crapshoot. You can, and depending on when you bought them, like if you have ones that were, say, 3 years old, they'll work differently. I mean, the pinouts and everything are the same, but the microprocessor in there that's been programmed will be different, and you'll find that between unit and unit, there's a lot of variation. Just, I guess that's what you get for $2. You know what I mean? So these are really worth the extra $2. So I feel really good. I found, like I say, a reasonable IR sensor and a reasonable ping sensor. I'm feeling like I'm getting some a little better, more reliable sensors.
If you want to spend a little more, this is like $30, but this is the Maxbotics sensor, and it's fairly solid. It's very reliable. And they come in different beam widths. It's a real nice sensor.
Yeah,
but
if you wanted 5 of those, Ted, that'd be the cost of a whole robot almost.
Yeah.
I bought one of those a long time ago, and I pulled it out of my parts drawer not too long ago when I was looking for sensors, obstacle sensors for my Romy. And I have to say, I wasn't, at least the one I got, which looked like the one you just had in your hand, I never was that terribly happy with it. I don't know, maybe I did something to it, but I never could get it to work very well. So
my experiences are similar, Chris. One of the problems, Ted, is they sell about 12 different variations of that sensor.
Right.
And depending on, I bought 2 that were recommended for autopilots, and I thought, oh dang, the community has recommended these sensors. I'm good to go. And I found they were very, very insensitive. Now, they weren't noisy. They were just kind of almost dead, you know what I mean? And then I got another one that somebody gave me that was part of a blimp project. It was pinging the ground to tell how far the little hydrogen blimp was. And that was a little better. So it could have been just the version. And that's, like I say, without some playing around, I'm not sure you can. Let me say it this way. I'm sure they're great sensors, but I do know you can get some that are just not good for your application. You got to get the right one, and they have a lot of them.
Right, and if you can use $5 sensors that do what you need, then you might as well.
These aren't going to go, I don't know, at 12 feet like the ones that David had. They're going to go 5 feet. That's it. Because after 5 feet, you get you're too far signal. Well, 5'2". Okay, it's 52, 53 inches, but essentially 5 feet. Anyway, I thought I'd put that in there because I have to say I was getting kind of excited about the sensors I'm finding.
I can go next because actually, as long as Kareem's around, I kind of wanted to reply to him. I had started to draft a response to his email in the mailing list about behaviors. So I'll give you a little background is that this CROS K-series robot operating system that I'm working on, I'm gradually adding more and more layers onto it. So now there's a behavior layer at the top. So I've got a roaming behavior that I mentioned, and I'll have an idle behavior and other things like that. So I've got another layer now on top of the basic subsumption architecture, and it all runs from a keyboard. So you can sit there and type, infrared center, infrared starboard, infrared port, and I can hit R for roam, and it'll start roaming. And it's using async IO, and it seems to be working, and I keep adding features. And so now the roaming behavior is a behavior that, because one thing I do like about Python over Java even is that you've got multiple inheritance. So the roam behavior is a behavior, but it also is a subclass of subscriber and will be a subclass of publisher as well. So it can subscribe to infrared sensor events, because it's going to now, as the roam, basically the roam behavior is as the robot moves forward, it uses the front infrared analog signal as a speed control. So as it gets closer to things, it slows down until it finally stops at a set distance. So the roam behavior actually needs to subscribe to those events. And then eventually it will publish events that will become suppression events on other behaviors. So there's kind of a low-level set of non-behaviors. They're actually just in the subsumption loop in more of the David's model, where at a 20 hertz, there's things happening. But then there's ballistic behaviors, and this is where Kareem's response comes in. There's ballistic behaviors that run at a higher level, like roam, that would effectively be interruptible by higher level behaviors, but effectively subsume all the lower level behaviors while they're running. So unless they get interrupted, the roam behavior will get interrupted by bumpers and things, but it'll basically be moving forward until it gets interrupted. And so you can see where the complexity in this is now, that you've got publishers and subscribers, and you've got at the lower level all the different things that happen to control the motor speed based on that level of interaction. And then if you get to an idle state or something triggers roam, then roam will take over as a ballistic behavior and now run interruptible by certain things, like let's say, for example, low battery or anything that's higher priority. But now I've got actual higher level behaviors. And that's kind of functional. I've actually got that working on a laptop. I'm mocking my motors right now, and I'm also mocking the sensors, but it won't be too hard to swap in the actual sensors and the actual motor controllers because I'm following the same pattern. But I kind of wanted to kind of go over that with Kareem present, because that whole idea of a ballistic behavior is obviously of interest to a lot of other people. Chris has raised a hand.
Well, I mean, I was going to say, I think you're using the term ballistic behavior wrong, in the sense that the way I understand your roaming, I'm not sure why you're calling that a ballistic behavior, right? Because ballistic behavior, the way I think of it at least, is
a bomb.
Your bumpers hit something, right? Now you got to back up, and you're backing up for 6 inches, and come hell or high water, you're backing up 6 inches or until whatever 3 seconds have elapsed, but nothing is interrupting that backup maneuver. That's a ballistic maneuver, right? You're not looking at any other sensors. You're backing up for 3 seconds or 6 inches, whatever comes first, and then you let things resume. So that's ballistic because you can't interrupt it. But if you're saying the roam behavior can be interrupted, by definition, it's no longer ballistic behavior.
Chris, okay, let me be clear. We're talking about the two terms, servo behaviors and ballistic behaviors, and all the servo behaviors are the ones that are running on that 20 hertz loop. I've chosen to make the roam behavior, a ballistic behavior, interruptible by other ballistic behaviors or by very, very high priority servo behaviors. So something like the battery going down gets triggered up into the ballistic behaviors as a high-level signal and can interrupt, but the servo behaviors do not interrupt the ballistic behaviors. And yes, you're right, avoidance of an obstacle would be actually a high-level ballistic behavior. I just haven't implemented that. So roam would be a lower priority ballistic behavior than obstacle avoidance ballistic behavior.
I think we need another term here, and I don't know if it exists, right?
Yeah.
Because
Ballistic, I agree with
even
Chris.
though roaming is not, maybe it's not a servo behavior by a certain definition of what that is, but it's certainly not a ballistic behavior either. So I don't know what to call it, but I wouldn't call it ballistic behavior.
I
Is
think it's
ballistic
just a low
behavior a
prior-
term of art?
Yeah, servo and ballistic are two terms of art.
And is it really well defined?
I think so. I think actually even MIT's people defined that. I can't remember who defined it, but it's been around for a long time. And in any case, all I would say about the roaming behavior is that it's a very low priority, like an idle behavior. It's a low priority ballistic behavior that can be interrupted by any other ballistic behavior, but not by servo behaviors. Now, a ballistic behavior can be triggered by a servo, or not a servo, by an event. So let's say a battery notification or a bumper says, hold on, we've hit something. It will trigger a higher priority ballistic behavior that will then, take over from anything else that's running.
No, I agree with Chris. Ballistic means that it's a behavior that is set, and once it's initiated, it's not stopped. It can't be stopped. It's equivalent to when you're throwing a football, and when it leaves your hand, there's no more control over it. That's a ballistic behavior. It obviously came from ballistic missiles, but
I do understand
that is the term.
Yeah.
I mean, that is well defined. I mean, I'm trying
And
to.
I'm not contradicting that, Doug. What I'm saying is that once a ballistic behavior is started, no servo behavior can interrupt that. But if a higher priority ballistic behavior comes along, it might. And so if let's say you're doing obstacle avoidance, and all of a sudden you get another notification that's higher priority, you could suppress that ballistic behavior because a higher priority one came along, but it would never be interrupted by a servo behavior.
Well, I guess the only way I could see that a ballistic behavior could be interrupted would be through an interrupt. And then it would only be temporary, and it would return back to the ballistic behavior. So,
Right.
I'm saying there's no, I mean, you really, in general, want to avoid ballistic behaviors. I mean, I agree that I've taken a shortcut every once in a while, especially exactly in the one Chris mentioned. For example, when I in a 6-can competition, when I put the can in the goal, what it does is it just moves backwards 12 inches or something like that, and then turns. And that 12 inches back is a ballistic behavior. I mean, once I initiate it, it just does it.
I think in the end we're just talking about terminology, so it kind of, it doesn't matter, it's just that it confuses people, right, if you use terminology different. But one litmus test, which was on that slide that I just flashed up, was, does your roam behavior ever complete?
Yes. It completes as soon as it gets to a point where it stops, which is when it gets to a obstacle. So, for example, it rides forward until it comes, as I said, the roam behavior is a fixed, bounded behavior that looks, when you first start it, let's say the robot sees nothing in front, it just drives forward roaming until it comes upon a barrier, and then it drives up to the barrier 20 centimeters away and stops. And that's the end. So it doesn't run into something. It's basically drive forward because we don't know where to go, roaming until it comes within 20 centimeters of a barrier, and then that behavior stops. And then some other behavior or a servo behavior might take over, like an obstacle avoidance behavior.
But you won't go back to roam? I mean, that's what I'm asking, right? Doesn't roam run continuously? I mean, yeah, you might find yourself doing something else while avoiding an obstacle, but when you're done avoiding the obstacle, are you not coming back to roam?
Roam finishes. I mean, once it comes up to an obstacle, it basically drives forward with no particular. I mean, I've defined roam my own way, which is it drives forward until it comes up to an obstacle and stops, and that's the end of the roam behavior. So
And then
it's a
wander
low
takes
level-
over.
It's a low priority, yeah, and then an obstacle avoidance would take over. The idea is that roam is a very low priority behavior that can be overridden by batteries or hitting something or anything that would come across. It's the lowest priority behavior, and that's why that's the first one I've designed. It's effectively an idle behavior.
So what do we call a behavior that is never ending?
That's a
and is-
servo behavior, I think.
Well, is it? Okay, always?
Isn't
Well-
it a default behavior?
Well, I've designed roam as my default. That if nothing else is going on, it just goes into idle and then runs roam. But I think that the behaviors that are running on that 20 hertz loop, the way David's working on his, that all the behaviors that interact in the consumption architecture are running as servo behaviors on a 20 hertz loop, whereas the higher level behaviors like roam or obstacle avoidance, which are, I think by definition, ballistic, that they start and try to complete. And the only change I'm making, by the way, as far as I see, to this model is that a ballistic behavior can never be interrupted except by a higher priority ballistic behavior. So yes, you've thrown the football, but if all of a sudden the nuclear missile comes through, you duck. I mean, you don't, whatever the higher priority happens to be. But generally, they would normally complete unless they're interrupted by something that says, hold on, you can't do that anymore. You must do something else instead because something higher priority came along.
Murray, if I can,
Yep, please.
I have to start by saying that I have no idea what you're talking about. I'm trying hard, but I can't figure it out. If you refer back to the talk, if I may be so bold, the things that were running inside that 25 hertz loop, the highest level, the highest priority behaviors are all ballistic behaviors. Those are the escape behaviors. Those are things that do things like back up, that know how to rotate through a certain number of degrees and know how to wiggle around and try to get free and so forth. They're called ballistic because once they're initiated, they can't be interrupted. Now, there's one exception to that. Ballistic behavior can interrupt itself. So if you're in the middle of, say, you hit something with a bumper and you're in the middle of doing a bumper behavior and you hit something else with the bumper, that restarts the behavior. Basically, if a ballistic behavior is interrupted, its only choice is to abort. Because if you were trying to go ahead 6 inches and then you were interrupted, when you come back, you can't do that anymore, or 3 seconds or whatever. So for me personally, the only ballistic behaviors I use are always the highest priority.
I don't disagree with any of what you
They're
said.
sitting inside. Well, okay. Well, maybe I'm just being slow tonight. That's very possible. But
No. I mean,
your description of what you're doing makes no sense to me at all. I can't figure it out at all.
Well, I don't.
Why
I
would you make what should be the lowest priority behavior, which would be navigation, roaming, as you call it? Why would you make that a high-level ballistic behavior? That makes no sense to me at all. Further, avoidance behaviors are not ballistic behaviors. They're servo behaviors. Reacting to the IR or to the sonar are servo behaviors, not ballistic behaviors. You see something on the left, you turn right until you don't see it anymore. Sure. Not for a specific amount of time, nor for a specific rotation. It's a servo behavior because it's fed back. So as I say, I'm struggling here, but I just don't understand what you're describing at all.
Well, okay, I'll try. That I agree that the normal use of the analog sensors is as you described it.
What do you mean by normal? How are you defining normal?
Well, normal as per your definition. That I've got 5.
Then you're saying your use.
Well, let me try.
David's use.
I've got 5 infrared sensors, and the normal servo use of them is as you described them. That they would normally be in the 20 hertz, in my case, 20 hertz loop, modifying the behavior of the robot in a servo behavior mode the way you've described it. Now, when I've talked about a higher level or a ballistic behavior, it's, as you said, uninterruptible. And the only change I believe I'm making to the terminology is that it can be interrupted by another ballistic behavior, which is, as you say, to abort. Now, in my case, I'm trying to create a hierarchy of priorities of ballistic behaviors. And so, for example, if I've got a obstacle avoidance behavior and it's now in that mode of trying to avoid an obstacle, it bumps into something else. And as you said, I could either try a different obstacle avoidance behavior, or I could restart the obstacle avoidance behavior, as you've described. And I think of those as ballistic behaviors.
You're
Now,
saying that when you restart, again, I'm lost. You're going to restart the IR avoidance behavior?
if while in the middle of that behavior, let's say we're running the robot and we run into something, we start the ballistic avoidance behavior, and then while doing that, we hit something else, we would, restart that behavior. Isn't that what you just described?
Not at all.
I thought I was reiterating what you just said.
There's no restarting of behaviors. They're all running all the time.
Okay, you said that okay, please reiterate what you said then, which was that if in the middle, you said there was one exception, that if in the middle of executing a ballistic behavior.
I didn't say a ballistic behavior. I said the escape behaviors. Those are the only ballistic behaviors on the robot. There are no higher level ballistic behaviors to interrupt them. The only thing that can interrupt them is something at their own level, at that highest level. They can interrupt themselves. So if you hit something with a bumper, you want to back up and rotate away. If in the course of backing up and rotating away, you hit something else, that resets that behavior. That has nothing to do with servo behaviors. That has nothing to do with IR avoidance or sonar avoidance or even navigation. Those things don't get reset and start over. They're always running.
Okay.
And I'm kind of with Doug on this. Ballistic behaviors, they're bugaboos, and they're to be avoided. We're just talking about a chassis. We're talking about driving a robot. There are other things, like when you're trying to manipulate a gripper or something like that, that require ballistic behaviors and can be handled with subsumption. But we're not discussing that. We're just discussing basically running around. And in that mode, at least the way I have implemented it, the very lowest behavior is what you're calling to roam. It's not a ballistic behavior. And the behaviors above it are also not ballistic behaviors. The only ballistic behaviors are in the very highest level in those escape behaviors. And they run in sequence. They don't interrupt each other.
Well, I can see your point about roam, and roam is simply an experiment because I needed a behavior to start with, and maybe I've made a mistake in choosing roam.
If you remember in my talk, if I can again be so bold, the first behavior I implemented was just to read a knob and pass those values along. And if you set the velocity to some number and rotation to 0, now you're driving in a straight line. So anything you add on top of that, when the behaviors above that are not running, you will run in a straight line. That's what that low-level default behavior does.
Well, in the Python code I've got right now, I only added this whole idea of a behavior manager and behaviors in the last week. And prior to that, everything, as far as I could tell, was running in a mode of what we have been calling servo behavior. So that if an infrared event comes through, it triggers some kind of a behavior. And that there would be
again, your terminology, if an event comes through, it triggers a behavior. That's not how servo behaviors work. There's not events, there's no triggering.
Okay, I'm coming from a different place in terms of the terminology. Clearly, that there's a message bus architecture in like Java, and we have events triggering and basically being put on the message bus. You have a publisher and a subscriber model. You have publishers sending events, like for example, my whole infrared set of sensors are publishing events onto an event bus, and subscribers are pulling those events off. So that's the terminology I'm using. Clearly, it's not the same terminology source as what you're using, but I'm using a model that is well known in at least the infrastructure world that I come from.
Well, let's back up a little bit and talk about, when you use the term servo behavior, and talk about what that actually means.
Okay.
Suppose that you are following a line or following a wall or something, and your behavior says, if I get off to one side that I correct the opposite direction so that I can follow a line or follow on for a wall. So that behavior is running continuously. When we refer to a servo behavior, that's what that means, that there is a function that's like a servo that's pulling the robot in one direction or another, depending on what that signal is. So it's not an event that's triggered, however it is under the hood that you're delivering that information. When we talk about a triggered event, that would be something like back up and rotate in place, where that is a ballistic behavior and it actually does have a beginning and an end and a trigger that sets it off. But the rest of the servo behaviors are not triggered by any sense, irrespective, as I say, of how you under the hood are passing that information around.
Well, and I guess all I can say is that the whole idea of a message bus architecture is predicated on this idea that you have messages published onto that bus. And once they're published, subscribers pull events off. So that's kind of underpinning the whole architecture. And so the terminology now of a subsumption architecture comes from a different place than that terminology, and there's this overlap between those two fields of terminology, which is where I'm sure a lot of this confusion is coming from.
Can I make an observation? Because it sounds like the message bus event that you're mentioning, Murray, would, in my way of thinking, be how data is sampled into a sampled system. So with each Java or whatever message event, you get a new bit of data that feeds into the discrete time domain, and then that's just an input to the loop. And it happens in your world, it happens to come through a message bus event.
Right.
But it's just another data sample in my way of thinking.
Okay. I mean, I'll try to be really clear about what's happening. That I have, 5 infrared sensors, and they're on an I2C device, and I have a little program running that samples that, and then if it sees anything of interest when it does the sample, let's say a bumper, left, right, or center bumper, and then the infrared ones, if they're within a certain distance, it creates an event. And that is a event publisher. So any of those events that are interesting at the level of the sensor or at that program, that little script that's running, any of those events that are interesting from the standpoint of the bumper itself or the sensor itself decides to publish the event. And it basically creates a message that has a payload, and the payload contains the event type and any data, let's say a distance, and that is put into a message, and the message gets put on the message bus, and that message bus it's been published to a message bus, and anybody who's interested in that particular event type has subscribed to that event type. So the motor subscriber subscribes to motor type events, and it pulls off those messages. And so you now have an architecture where you can send messages on, publish messages onto the bus, and have other things subscribing to particular message types. And if they receive a message, they can pull the data out and say, oh, this is a distance of this infrared sensor. And that architecture is a very, very common architecture in large systems and small systems. And all I've tried to do is implement that in Python using an async IO toolkit, because I couldn't do it in threading. Now, on top of that, I'm building a subsumption architecture. And of course, we've now got 3 different kinds of terminology all intermixing, maybe even 4.
Well,
so I'm sure that's where a lot of this confusion is coming from, is just the simple mix of different terminologies from different domains.
Murray, anything that publishes is a servo. If it publishes a message, it's a servo behavior. If it's a ballistic behavior, there's no publishing. Otherwise, there's no chance for feedback. It's just doing it. So that's a way of thinking in your terms, the difference between a servo behavior and a ballistic behavior. So like I say, if it publishes, it's a servo behavior. If it does, because it's essentially expecting some sort of feedback. So a ballistic behavior, like let's use the backup behavior. If you said back up 6 inches, it doesn't care that you step behind it at 3 inches. It's going to hit your leg and spin its wheels until it thinks it's gone 6 inches and stop. It doesn't
But is-
care. It doesn't
Is
care.
that a good thing or a bad thing, though? I mean, wouldn't you
Well,
want to?
that's
If you had
why
a bumper
that's why we say we generally try to avoid ballistic behaviors. You can't always do it, but it's generally a good idea to do it.
but if you had a bumper on the back,
Maybe this would be helpful to distinguish those. Following on what Doug just said, if you're driving along with a servo behavior like an IR sensor that's guiding you along some path or along a wall or something, then that behavior stops when the sensing stops. That is, if I drive along and I see something, I begin to rotate away from it. I continue to rotate until I don't see it anymore. So the termination of that particular sequence of behaviors is when I no longer see it. Now with a bumper behavior, you just press that bumper once and quick, and then it's not pressed anymore. But the behavior has to keep going, even though in the lack of an input signal. That's why it's called a ballistic behavior, because it's set off by that bumper press, but it continues long after the bumper press has ended. Does that help?
yeah, no, I try to maintain that I don't think that I'm in conflict with what you guys are saying. The only thing I can say to Doug is that if my robot had a bumper in the back, and while backing up on a ballistic behavior, a obstacle avoidance behavior, if I had a bumper in the back, that bumper would have a higher priority than the bumper on the front because I almost never use it.
Why?
And therefore, it would interrupt the backing up behavior and say, hold on a second, you can't back up any further.
That just seems like it's part of the backup behavior to me. Backup behavior itself monitors whether a back bumper has been hit.
So that would be another servo behavior.
And aborts or completes its behavior if that happens before it finishes backing up. My old three-wheel robot, SRO4, sometimes when it would back up over things and tilt up at an angle like that. So I had one of those little steel balls like in a pinball machine, a tilt sensor, and when it tilted up like that, it would set up that ball, and that aborted the back behavior. It says you can't back up anymore, you're running into something. But that's just that's not a higher priority behavior, that's just part of the backup behavior. You back up until you arrive at this location, or 3 seconds have passed, or you hit something with your rear bumper. That's all
so
determination.
I don't think I'm in conflict with what you guys are saying. Maybe
Why is it that you think you want multiple ballistic behaviors at different priorities? What problem are you trying to solve with that?
Well, okay. I don't think at the level of the servo behaviors I'm in conflict. I think I understand what you guys have done, and I think that despite the fact that my architecture is a lot more complicated, and I'm using events and all that stuff, I think that the overall behavior will still be mostly servo behaviors. And like I said, this whole idea of a higher level behavior, which I maybe mistakenly called a ballistic behavior, was this idea that above the basic operation of the servo behaviors, there might be behaviors that kind of take over and do things beyond what the servo behaviors are doing. But I guess what I'm getting from David is that there's no need for that, actually, that you effectively have the prioritization of all the servo behaviors anyway, and you can handle most anything without having to resort to a ballistic behavior.
Outlaw all ballistic behaviors.
Pardon?
So my question is, like my team's robot, they have some long-running processes that are what they would call a set and forget behavior. I want to understand if this is a ballistic behavior, right? So this is a series of movements of, say, the turret and the elbow and a gripper, and it has to go through the sequence. It is entirely interruptible. It's not something that can't be overridden. Is that a ballistic behavior or is that a servo behavior?
Okay, here I put
I think the thing is that I was defining two hierarchies: a hierarchy of servo behaviors and a hierarchy of ballistic behaviors, with the idea that the latter, the ballistic behaviors, were kind of somehow higher level behaviors with longer term trajectories, maybe that if I wanted to create a behavior that was, because I understand the idea of an emergent set of behaviors, that you set up some relatively simple servo behaviors and you get emergent behaviors out of that you haven't even defined. And man, that's the whole idea of an emergent behavior. Now, what I was trying to do with this idea of higher level behaviors was to create sort of tasks for the robot that you could set up that could be triggered through something, maybe idle or something, where once triggered, they can be interrupted by a higher level ballistic, but they effectively were higher level tasks, like let's say navigate to a cone or something like that. And you could define navigation to a cone through servo behaviors, but I was trying to come up with an architecture where you could say, do these things, so long as you're not interrupted by a higher level behavior, do these things until you get to some endpoint, and then you finish this behavior.
I'm still lost why you need to do this. Your example is to navigate to a cone, which in my view is a very low level behavior. It's the lowest level behavior. So if I understood your response to my question was, what problem are you trying to solve? And the answer really seems to be, well, I don't know. Maybe some problem will emerge in the future that. And I have to tell you, Mary, the way I build robots is I build from the bottom up. You know, Kareem's talked about top down and bottom up. I build from the bottom up so that I get little pieces working and I add those. So the idea of adding something that may someday be needed for some problem I don't have right now is antithetical to the way I work.
Fair enough. And like I said, this whole idea of having behaviors that were defined at a different level than the servo behaviors, this upper level behavior, whatever I've been calling it, maybe isn't necessary. The reason, and I'll only defend myself this last time, the reason I decided that I thought this was a good idea is that some of the behaviors I had envisaged for the robot were ones that I couldn't in my head figure out how to implement as simple servo behaviors, that they were there.
The lack of imagination led you to this huge dark hole. Murray, to your point, there are ways you can do that. We hadn't really focused on them much, but the order in which tasks priority is arranged can be changed. So if you feel like you need to change to some other kind of mode of behavior, you can actually change the order of priority of behavior. So that's one way to do it. On all my robots except JBot, those are fixed, but JBot can rearrange it if it wants to, but that's a solution that's looking for a problem. I've never used it. But that's a possibility. And there are other things that are along those same lines. Everything we've talked about sort of assumes that there's only one subsumption loop running on the robot, and that's not necessarily true. Certainly, if you have more complex actuators to handle, there'll be more than one control loop. So there are other ways to do that. There are also some ways to cheat in terms of cheating the purity of the subsumption architecture. You can have out-of-band signaling such that processes know something about what the other processes are doing and what their states are and so forth.
Well, the way I've got it set up right now is that because I can actually run this whole thing on a laptop, because I actually been doing it on the train while I'm going to work, is I can actually hit keys on the keyboard and fake a robot. So the whole thing runs without an actual robot. It's a simulator at this point. But I can also run it with the gamepad. And the idea with the gamepad is that the signals coming off the gamepad are firing events, the same kind of events, onto the message bus. And therefore, I've got keyboard or gamepad can control a robot. And eventually, of course, the sensors would control the robot.
Will they let you run the robot up and down in the aisle on the train?
Oh, yeah. I don't know. That'd be kind of cool. Yeah. Kiwis might not attack it and kill it like Americans do. But go ahead.
I was hearing, Marie, since you already have this event set up, I think, how about you have the feedback doing these the routine feedback, and have some higher level, like a state machine type of thing, that your event will drive it. I think if you have it, it's a good thing. You have this event, you can have that event kick the behavior into different, like to configure, for example, to configure the feedback into different modes, or break it, or completely change the lower level. But I'm thinking whether it's predefined motion on the feedback. It's kind of a real-time interrupt-driven motion, but the behavior-wise could be, could be on a different time scale. But you have a lot of flexibility if you have this event to configure the real-time behavior to a different mode.
I'm kind of with Carl on this one, in that I think of the way you're describing a message bus. It's just a way of getting sensor flow into some sort of control loop, right? Or
Yes.
some sort of behaviors that you're running. And I'm seeing and I would be careful about thinking that of that in the way you do with systems applications, where you're responding to events and only executing code when those events come in. The way that David is talking about his subsumption architecture is all of those behaviors are running all of the time, and they're just suppressing each other's access to the outputs, which are the motors, right? If we're simplifying it to just say 2 motors for navigation, just for example. Right, so that's the scarce resource that you have to arbitrate, but that doesn't mean that the behaviors can't all be running all the time on every single loop. And the subsumption part of it is just how your priority scheme naturally suppresses other behaviors from taking control of those, in this case, motor resources. But I wouldn't confuse that with getting information off of a message bus. To me, that's just a different way of streaming sensor data into your control loop.
No, I entirely agree that the message bus is simply how, and the whole idea of a publish and subscribe system is all that is just machinery. It's plumbing, and it's just how I transfer information around between the publishers and subscribers. And the one benefit is that any particular, and by the way, all the publishers and subscribers actually are all finite state machines. And so their state is altered by whether they get certain kinds of messages or not. And so the way this works actually is that anything can be a publisher or a subscriber, or even both. And the reason I even designed this whole idea of a behavior class was that I wanted to have something that could effectively wrap both publishing and subscribing. So like Roam was my example, a really poor example apparently. But the idea is that the Roam behavior both subscribed to events like this infrared the analog center infrared event, which is a particular event. It would subscribe to that event, but it also publishes messages to the motor controller saying, please drive forward or whatever. And so this was an attempt to come up with a way of having a particular Python class that implemented both publisher and subscriber, and therefore could both receive and send messages, and also could suppress messages to other behaviors. And so you're right, Kareem, this is just plumbing. It's just how I'm sending messages and information between different components of this OS that I'm writing.
Kareem said earlier, ban all ballistic behaviors. Kareem, did I hear you correctly?
Yes, you did.
Can you expound on that?
No, it was just every example that I've heard tonight. It seems to me that there's a case where they are either interruptible or self-interruptible. So the portion of the description of a ballistic behavior that I'm having a problem with is the fact that it's by definition not interruptible.
But would you say that's true, that a ballistic behavior once running isn't interruptible, but couldn't it be interrupted by an even higher level behavior? Like a higher priority, sorry.
Well, again, that partially this is a question of what do you mean by interrupted, right? It's really, is it something else is taking control over the actuators that it's wanting to control, and for a particular robot, it's not like I've thought this through really well, but for any particular robot, you're going to have a natural series of behaviors that you're going to have defined, but add something new. I've added a temperature sensor to detect when the lithium-ion battery is burning. Well, maybe that is a higher priority than anything else, right? And you could just keep adding more and more things, and then just that eventually. But I don't know that there's a necessity to have the single highest priority behavior. Maybe, I don't know.
Well, in my case, all of these events, actually, I hard code, but it could be modified, but I've hard coded for every event type a priority number. And the highest priority is the battery's running out. And
are the priority numbers exclusive?
No, they don't have to be. They can, so a whole bunch, like all the infrared sensors share the same priority.
Okay.
No, they don't have to be. If you're familiar with Python, you can have an enum class where you enumerate all the different objects. And so I've got each event type as an individual object, and each one has an integer number that is the priority. So you could have everything be the same priority, but I've prioritized. So like battery running out is, I don't have a fire sensor, but I could have a high priority fire sensor. And that would say, okay, shut down the robot, the batteries are running out. That's the highest priority. But then everything below that is a different priority. And like the bumper sensors are obviously higher priority than the infrared ones. But that's kind of how that works. And you could, yes, add, and the high idea of this whole architecture is that I can continually add new event types for new sensors and new facilities that I'm trying to design.
Well, I've yet to hear anybody make an argument why you have to have a ballistic behavior at all.
Well, my understanding is
I agree with that. And Kareem, if I can expand a little bit on what you were saying earlier, if I understood correctly, when you were describing all the behaviors running simultaneously, and maybe that's not so obvious, that let's say, for example, you're navigating to a particular waypoint or whatever, and that's a low-level behavior. And along the way, your sonar or your IR or something see an object and they turn you away. During that time you're being turned away, the navigation starts to say, no, turn left, we're going the wrong way. It's continually running. It's just being ignored until the sonar or the IR or whatever avoidance behavior stops, at which point it begins to be acknowledged. But all the behaviors are running all the time, each with their own different opinion about what the actuators should be doing. And the subsumption architecture is a very simple model. I mean, it's good Lord, computer science 1955, which is just, they're arranged in a priority and the highest priority wins.
I think you guys we're all getting hung up on the terminology here, because at the end of the day, none of us have purely analog robots, which by definition means they're all digital robots, which means that they're all ballistic. They're absolutely all ballistic in between sample periods. Right? It issues a voltage to the motor, blinds are shut, whatever's going to happen is going to happen, and it's ballistic until the next sample period. So it's all ballistic on the inside. And at the end of the day, but what that tells me, though, taking it to that extreme, what that tells me is that what we seem to be debating here, talking about is, okay, how do we organize the behaviors such that some of them are more interruptible and some of them are less interruptible, such that some of them have a higher priority over others? And I think that's what this whole discussion is about, is one of organization and thinking.
And I think we should let Kelly have his question or a comment. The only thing I would say is that I don't think that I'm in conflict with either David or Kareem or anybody, except for potentially this whole idea of a higher level behavior, which I was trying to define and apparently have failed. But I have read all the stuff from MIT, and I've read David's stuff, and I'm actually trying to build something that's in, again, I'm not sure of the word compliance, but I'm trying to build something that kind of agrees with what David has done. And I think that it's only because of terminology and my potentially mistaken notion of what's interruptible and priority that this has come about. But I do think it's mostly terminology, that I have created a message bus architecture, publish, subscribe, all that stuff, but it is effectively trying to do the same thing as what David does on a simple loop that just goes around. I'm doing it with a whole bunch of messages and a whole bunch of extra shit in there, but it's theoretically trying to do the same thing. In any case, Kelly, please.
Thanks. I have a rover that's kind of a telepresence type architecture. It has a 4G connection to a cloud where I have a driving interface. And because it's over 4G and all and the web, there's latency involved with every action that I make remotely and everything. But so when I tell it to drive forward, it's normally I tell it to drive forward 6 inches, 12 inches, or 24 inches, and all, and those are unstoppable. Those events happen. There's no stopping them. And so I use this rover for wildlife photography around creeks and things. So if I tell it to drive forward too far, it will go into the creek and everything. And so I've considered adding a sensor that detects a drop-off using sonar and manually interrupt the power on it. So then whenever I get feedback over the web, it says the engine was cut off because of a sonar event and cancel the action that was happening. Ballistic action actually was stopped by hardware, not by software, but by hardware. And then I'm given a choice to tell it override and finish anyway, or terminate that last function. But I've got a couple of events too, like my rover has a wildlife watching mode that it watches for any movement with the camera, and if it sees movement, it takes a picture, and then about every 2 minutes, it calls back to the cloud and says, "Are there any commands waiting?" Like if I set it to watch for wildlife for 60 minutes, it's kind of a ballistic action and all, but every 2 minutes, it's going to check to see, is there a cancel command waiting in the buffer and everything? And if there is, it'll stop it and everything. And then I can reposition the rover to a new position and then put it into webcam mode again and watch for movement.
Cool.
So I have a bunch of these potentially ballistic actions there that I have considered adding some type of mechanical interrupt, and because of the latency involved. And so that's something I've been dealing with. So in a way, what Robots New Zealand is describing is kind of what they call a mission plan, a mission and everything. And then there's updates, and those are on a higher level than just actions and sensors and things like that and everything.
Well, Kelly, actually, it's a really interesting point you'd make, because actually the whole idea I had for these higher level behaviors was literally that if you have a telepresence robot, like literally on Mars, where you've got a 7-minute or a 4-minute delay, you tell the robot to go somewhere, go to that next rock, and the robot uses servo behaviors to avoid obstacles, and it does its thing, but it's got this overriding job to go and do something. And that's kind of the point I was trying to design, was something where I could say to the robot, this is a goal that I've given you. That's a higher level goal that I give you as a robot. But the robot then goes off and does its own thing underneath that as servo behaviors with an overriding goal. And that was quite literally the idea that I had, was from Mars rovers, that they do get these telepresence commands.
One of my planned features was to tell it, follow the path for 3 meters, where if there was potentially a black dirt path surrounded by green grass, it would use the images to stay down the middle of the path and travel 3 meters and stop, and then wait for a new instruction and all. Because latency involved, it's very difficult to drive a rover down a rabbit trail in a creek and all full of briars and drop-offs and things. So.
Well, and in fact, I got one of these little game pads, a Bluetooth game pad, and the idea that I had was that I would let the robot go and let it do its thing with its own set of servo behaviors, and then I would, by pushing a certain button, tell it that I want to give you a higher level goal, and it would go off and do that. And that's mistakenly what I've been calling a ballistic behavior.
But my actions are little ballistic actions and everything that I can't currently interrupt them in any way, but I would like to with some mechanical means in the future.
That's interesting.
But this is like one of my little wildlife rovers here, and it's based on a tank chassis that you can get these pretty cheap for like $23. And this one, actually, this is my Grove sensor model. It's got a a Grove hub in the top of it here that's just loaded with I2C and analog and digital sensors there, where you can buy any off-the-shelf seed sensor and just plug it in, and it's on top of a Raspberry. But this has got more features than I've had time to program. It's even got a GPS on this tower, but I'm not sure that that's suitable for rabbit trails. That's just not accurate enough. And other problem, if you go into a creek bed, like where you want to see ducks, you lose GPS satellites very quickly. So that's why I was thinking about using images for following trails and possibly even dropping out fluorescent colored pellets along the way to use as breadcrumbs to navigate back out and everything. So
that's very cool.
So,
Do you have you published any of the films or photographs or not films, videos or photographs that you've taken?
I have just one or two samples are on YouTube, and all I need to post. I do want to create some videos and post them and everything. I've got some of these designs are 3D printable. I have them at Cattern.com.
If you put something in the link here, I'd love to see what you've done. It sounds really cool.
Right.
Those do sound cool. I'm still struggling with whether we want to call things like that ballistic behavior, since the way I'm hearing it in the art is quite the opposite. But that doesn't mean that there aren't supervisory behaviors, or I don't know what the language is, but there are larger goals, whether it's following a particular navigation path or something like that. But it's still interruptible.
Well,
and I have an example, so maybe this would get some feedback from you. One of the behaviors that I can that invoke, one of the ballistic behaviors I can invoke on my robots is to rotate in place through a certain number of degrees, and because it knows the number of degrees, it can arrange an acceleration and deceleration ramp, and produce a nice, pretty rotation, and it's very accurate. The only way that can be interrupted is if it hits something while it's rotating. So basically what that does is abort. In my humble estimation, the only way true ballistic behavior can be interrupted is to be aborted. It can't be subsumed, because that blows up the whole ballisticness of the thing. So if I understand what you're saying that you can envision that same thing could be done without having to resort to ballistic means. Is that right?
You're asking me or Kareem?
Kareem.
Can be without having to resort to, well, if I think I also heard ballistic defined as not taking any input, right? And if you're taking input inside your behavior, that's what is your progress in terms of degrees of rotation so far? Is that still a ballistic behavior?
How about if you're going to back up and you're measuring your progress as to how far you backed up, or even measuring the time, how much time you have backed up?
Yeah, I'm struggling to find an example of the ballistic behavior
with no
actually,
input. I agree.
I think the thing is that I've mistakenly used the word ballistic in a way that is obviously created a lot of confusion. But actually, Kelly's point is the one that I would like to reiterate, which is actually my goal. David, you were asking what my goal was. The goal was that I could set my robot loose, and it would do its thing with its own emergent behaviors. And at some point, I'd say, I want you to do something particular, like a moth behavior or something like that. And I could push a button on here, and it would basically now get this higher level behavior, like a moth behavior. And it would do that until it got to the end of that. Either I turned it off or it finished the behavior. But that higher level behavior would operate as a higher level goal, sort of like NASA sending a message to the Mars rover saying, I want you to go to that rock. And then it would do whatever.
A moth behavior in your example, you're talking about to move toward a light, right? So that's a low level behavior, because it also has to have higher level avoidance behaviors running in order to keep it from running into things while it's seeking toward a light, right? So really, you don't need to have some high level behavior. You just need to have an enable bit that turns on and off the photo sensors, right?
Right. And
you
in
could
fact,
say,
of course,
okay, that's a cockroach behavior instead of a moth behavior by inverting that behavior.
And so
it doesn't require anything other than just pushing a button and setting a bit that says run the photo behavior. And maybe you have another bit that says move away from lights rather than toward them, what we call cockroach behavior, which I found to be actually uninteresting. The robot just ends up banging around behind a couch or something. You know, it's much more.
I'm using bad examples because I'm trying to get across the idea. I agree, David, that a moth behavior could be simply a suppressed or unsuppressed low-level servo behavior. In fact,
I would rather use the term enabled. The suppressed suggests that it's running and that something else is suppressing. But enable just means it's not running. So you can enable and disable that behavior. And I don't see why that would require a higher level behavior. But Maria, as I say, maybe I'm just misunderstanding what you're trying to do.
It's a conflict of terminology, and I keep using the wrong examples. But I kind of just want to get back to that idea that the whole gist of what I was trying to accomplish is effectively what Kelly was talking about, that in a telerobotic system where you have the robot just programmed with a set of priorities, that I could, and I won't use the moth behavior as an example because, again, that doesn't have to be programmed separately. But the idea would be is you could say to the robot, I want to do something specific. And maybe, you're right, maybe all of these behaviors could be programmed in as normal servo behaviors, and we can just avoid ballistic behaviors entirely. But I don't think that's what NASA does. They say to the robot, you've got a goal, and I want you to, at a higher level, I want you to go to this particular waypoint, and maybe you can program all those using servo behaviors. I don't know. But the idea was that as a telepresence robot, you could tell the robot, I wanted you to do something. And that would be a higher level goal than these servo behaviors.
All right. I will just respond by saying that I'm eagerly looking forward to you getting your gold star on your forehead when you actually turn your robot on and show us doing these things. Show your robot actually doing these things. I think that's something that I will anticipate.
I know. I did show the actual thing running last week, didn't I?
Mm-hmm. And it was doing all these things?
Well, it's simulating the things. It is, you know, if we assume that I can hit a button on the keyboard and that's the same as an infrared sensor, yes, it actually already functions.
You know, as you guys know, I fly radio control helicopters and have been on and off involved in other RC projects in my lifetime. And one of the things I noticed that differentiates that hobby from robotics is that when you pick up a magazine to read an article, the article will be, here's a guy showing his airplane, his helicopter, his car, doing this incredibly cool thing. So that naturally raises the question, how did you do that cool thing? And here's an article explaining how that cool thing was done. You know, hovering tail down just a few feet in front of him, which is a common skill they all have now. Whereas when I read things in, you know, Servo or any of the robot magazines that have come and gone over the years, they always put, in my view, the cart before the horse. Here's this sensor, here's this software. Just imagine all the wonderful things you'll be able to do with it. Nobody says, here is a robot doing an incredible thing. Here is how I did it. As I say, that seems to me the cart before the horse. So I'm much more easily impressed by seeing the behavior first and seeing how efficacious it is, and then understanding how it works, rather than starting the other way around.
But David, that seems a bit unfair. In order for me to do
now, that's coming from you who think my code needs to be modernized.
I know, that's not fair either. I have not criticized your code at all. I think what you've done is pretty astounding. But in order for me to do this, I have to develop the code. And I actually have functional code. I'm mocking the motor controller because it's not connected to real motors, but I actually can push a button and say, go a certain speed or whatever. And the motor controller, the mocked motor controller, does what I ask it to do. I've got a functional software system.
Rodney Brooks taught us that simulations are doomed to succeed.
It's only simulated while I'm in development. You've got to go through a development process before you can put it on the robot, and I'm in the middle of that right now.
I'm not trying to give you trouble, Murray. I'm just saying that it seems to me that
Yeah, I think you are.
that you're trying to solve real high-level problems that you're nowhere near approaching on your actual physical robot. My suggestion is to start from the bottom and work up.
Well,
I want to see Kelly's robot.
Yeah, I do too. Put it this way, David, I'm pretty close. The mocked robot motor controllers and the sensors are identical to the actual sensors and the motor controllers. So at the point where this thing seems to run and it's pretty close, I could theoretically swap it over to the real one. I might have got sidetracked for the last week trying to create this behavior model, but that's maybe not necessary. That I could do it just with the servo behaviors. Anyway.
We're driving them away.
Yeah, sorry.
Hey, Kelly, can you show us your
I gotta run.
robot again?
I didn't see it either. So you can show it. I appreciate it.
Okay. So the front green is the GPS? Is that what you said? And excuse me. I guess that's the back. That's the GPS there. And then the camera casing. You must be muted. You're muted, Kelly.
There we go.
Yeah.
Yeah, there's the Seeds Studio sonar there in the bottom in the bumper, and Raspberry Pi 2 camera, and GPS in the tower back here. Try to get it as far from the motors as possible.
Yeah.
And
by any chance, are one of those panels easily to take off? Well, let me look at the front. You don't have to. I'm just in the front. It looks like you've got another sonar location in the front, or what?
Yes, actually, I updated this body so that I did not have to make a special holder for the sonar.
Yeah.
So these openings in this body is a new feature that I'm not even using yet. I wanted to, because this rover system, the print time is pretty significant. I mean, it'll keep your printer busy for a week printing all these body parts.
You made the tank part too?
The tank part is off the shelf. You can get those from
okay. Yeah, I was going to say, that would be a lot of work.
Yeah, it's got so many moving parts, it's not worth making. When you can pick one of them up for $23 and it has 2 motors in it, right out of the box.
Yeah.
And got the Raspberry Pi there, and got the
Grove Shield.
Yeah. Okay. They've got a couple of styles of those Grove Shields that are.
What is that? It looks like is that a disc in the front for storage? What's that in the front?
I think it's my USB cable that I've got running around from the front to the back and everything.
Okay, I got you.
Cable management, or regular USB cables are a pain in the butt for anything this size. And so I've actually got a newer design there where the USB cables are less of a problem.
Are you able to run that in the rain or over wet ground?
Oh, it runs. Yeah, I have actually run it in the creek over sandbars that were too soft for me to walk on. It could go right up the edge of the water and hardly just leave a few little scratches there in the sand. And so it's very all-terrain. And I did find, though, that if I try to climb up a creek bank that's too steep, it will fall back onto its back like a turtle. So, that's the only.
Kelly, when you're using it to take your wildlife pictures, is it out of your field of view, or are you there where you can see it?
I have a 4G modem in it, so I could actually leave it at in Collin Creek in a wooded area near where I work, and then go home and control it remotely for about 6 hours. So
and nobody steals it and runs off with it?
I have literally, our company has a cyclone fence between the creek and their property. So it's an area that's like no man's land. The other side of the creek is actually a public park over there near Renner and 75.
Yeah.
But there's a peninsula that's fenced off, that I actually had a trail in there where I could go in there and place the rover inside there in the fenced in area.
Okay.
And I had a second spot too, but a homeless person moved in there, so I don't use that one because they would steal it.
Yeah.
Or take it.
You know what my question is there any way Doug can get another icon on his desktop? Is it possible?
Well, they go off to the side. I can't see those ones on the side. I'm thinking of getting a second monitor so I can put it over there on the side.
Oh, you forget to turn on that second monitor. It's going to dump all your icons on one screen, though.
Yeah.
Yeah.
Okay. Well, thanks, Kelly. I saw it before, but I didn't get I didn't get a good view of it. I didn't have you pinned up full screen, so I was just looking through a little square. That was much better. I appreciate it.
Well, Doug, if we can do repeats, I missed your presentation of the IR sensor that you're going to work with. Could you hold it up and let me see it?
Okay. Let me. All right. Where am I?
Probably doesn't look any different than the SRO4 though, right?
Oh, which one? Are you looking at the ultrasonic one or the? You said IR sensor.
I didn't get on until about 8 o'clock, and you were saying so. That's the IR sensor I've settled on.
Yeah, that's one right there. It's Pololu part 4071.
Did you put it in the chat?
Last week. I don't think I don't.
No, you did. The ultrasonic is the Seed Studio one. You put it in the chat.
Yeah.
I can go ahead and repost it if you want. I've got it right here because I was interested. I'll go ahead and repost it.
Is that the Pololu distance center with output 130 centimeters max?
Yes, and it's on sale.
And it's on sale. Okay.
Yeah. Okay. And you have to look up the code. It's on their sale or special page.
Okay.
But the Polo part 4071.
And how well did that work outdoors, Doug? I know you already went over all this.
Okay, I didn't go in super bright light, just normal daylight. Okay, you know what today was like. Okay, it was slightly overcast today. So, and at that point, what I saw when the sensor was within 20 inches of the front of the robot, it was 100% reads. At about 30 inches, we're getting less than 100%. Even when you get out to its full range of 50 inches or whatever it is, you're only picking up a few. Every once in a while it would pop one. So it's not as good as it is indoors. Indoors at 51, what they'd say 130 centimeters, it'll get it. It's not a problem in normal indoor environment. Now, if you're talking about Ross Perot Museum, I don't know. That's a little weird. But I would say in a makerspace room, I would say it'd probably be okay. They're very, very solid. I really like them. I mentioned last week that at about half range or slightly, maybe 2/3 range, I was able to get a nice Gaussian distribution of reads, and I had a standard deviation of 5 millimeters. So that means plus or minus 15 for the full Gaussian distribution. So, so if you wanted to know something dead nuts, like, oh God, it's exactly 100 centimeters away, it might not be the best for that unless you wanted to sample a long time and get a distribution. But if you're talking about avoidance, it's very nice. It's fine. So I'm looking at it as a replacement for the IR sharp sensors. Since
What sort of pattern do those have? Is it like a laser, or is it?
I believe it's an IR diode.
Is it a structured light kind of thing?
I don't know. I will say this. I mean, when I look at the sensor looks like one of those what do they call them? VL05 / something sensors. It looks like that. It looks like the two. The one that has the big square sensor lens in the front. But I can't guarantee that's the sensor. There might be somebody else using a similar package. I believe they put a microprocessor on the back, and what they're doing with it is they giving it a 1 to 2 millimeter pulse that occurs every 10 milliseconds. All right. So with multiple ones, they're not in sync at all. It's not like a servo where one goes off, the next one goes off, and the next one goes off. They're going off all the time. And so when you're running your loop, you don't want a blocking sensor. You don't want a blocking code, and you want to be able to ignore the 8 milliseconds. It's not doing anything on any given sensor. So that's why I'm using pin change interrupts, because this happens to be on an Arduino Mega. But if you were using an STM, you just have any pin can be an interrupt, so it's not a big deal. But they have very limited internal interrupts on this. You have to use, external interrupts.
So it has like a natural data rate of 100 hertz?
Yep, that one does. And I also said they have an enable pin, and I said I tried it, and that's not a smart move, because when you turn it when it's off and you hit the enable on, it takes 60 milliseconds before you get your first pulse. So that's not a smart mode to be in.
That's that microprocessor coming up.
Yeah, I don't know. So I would just say that I'm just really, like I say, they seem to be pretty solid. I'm pretty happy with them. I went ahead and ordered another 3. I think the 130 centimeter, the 4071, I think they have 3 sensors. I think it's the sweet spot sensor because it has the highest data rate. They also have one that supposedly goes out to 2 meters. All right, but I think it's a 4072, and but it's only got a refresh rate of, I think, 30, if I remember right. So, like I said, I think the 4071 is the sweet spot sensor. And like I say, I haven't tried it out in Texas Super, where when you look at your cone and all you see is a white corner. When you see, I'm sure you've seen that, David. When all it's there is a white. Because no matter how your camera's adjusted, it's just white. I don't know what it looks like then, but we'll see.
You need to put sunglasses on your robot, right?
Well, hey, that's what I've done. I actually took a lens out of a polarized lens out of sunglasses and made an adapter for my 12 millimeter thing. It looks real funny. It looks like an eye sticking out.
I had to use a neutral density. I just had a neutral density photographic lens outdoors because it just saturates the camera.
Yeah.
That whole sun thing.
Yeah. Well, I think, I'm not sure, but I believe Scott's doing a brightness control on his. I think he has if I remember right, he has like a solar cell or a cadmium sulfide cell and he's using that to cut the gain down. But I don't know if he's got other filters on it or not. So, but anyway, yeah, Murray, I got a lens out of a pair of old sunglasses. So, and I've also got some polarizing film material that I'm playing around with, but I don't know. Yeah,
There they are.
yeah, well, that's a good example.
Yeah.
Bit
Well,
like
you know-
Tom Cruise.
The problem with those, Ray, is those are linearly polarized, and the sunglasses I think are circularly polarized. So there's, I think, a little bit difference. I don't know if it makes any difference. We'll find out.
You know, Doug, when I walk outside from a dark room, it whites out for my human eyes, at least for a moment.
Yeah. Well, like I say, I've looked at that cone sometimes under a bright light, and like I say,
Well, Doug, there are those camera lenses or camera filters you can buy, which are actually both, two actual polarized lenses next to each other, and you can rotate them across each other. Yeah, exactly.
Well, that's what I was trying to do with this polarized film I bought. I literally cut out 2 discs and then turn them and see till I get a way I think it might work and pop it on there. But I don't know if, like I say, I'm still screwing around. Right now, I got other problems sitting in front of it.
You know, I'll be interested to hear what Scott comes up with, because I tried something like that, but what you're saying basically is that the camera, brightness and contrast are going to be changing dynamically as you drive out of the shade and into the sun. And I found that for my purposes, that really screwed up my ability to try to hone in on certain, colors and hues and so forth.
Yeah, well, like I say, that would be interesting is if you could somehow sweep your brightness trying to look for the biggest blob. Otherwise, you just set the brightness at the different levels and say, okay, here's where the biggest blob is. I'm going to sit there, and maybe then once you found it, you're going to just wiggle around it a little bit, try to maximize the blob for the thing. But again, that's probably 2 years down the road for me.
Well, didn't Carl, a few years ago, he and a team won an award for having a little robot that could recognize objects?
Beer bottles, I believe.
Yeah. Isn't that the right way to recognize cones rather than just as blobs of color?
Well, I've got something called. I've got some slight AI stuff that's supposed to be the pixie of AI. It's something called Huffy Lens or something like that, and I'm looking at that to see if it would be useful for actually seeing a cone shape. The problem is when I look at this AI stuff, it's only about 50 to 75% effective usually on small computers, and so I'm not sure. It might be useful, but
Well, I thought that the thing Carl did. Carl, are you out there? I thought the thing that he did, he uploaded to the cloud and used some cloud training.
Oh yeah. But
he's using. I think he was using some form of cognitive services or something along those lines. But what they've got going on now, you still use the cognitive services, but you train up a model in the cloud. Like you give it 50 pictures of the thing you care about. You can get. For the most part, you need to give 5 pictures of the thing to get it started going. But they really want about 35 to 50 pictures of it, and then it trains it. You train it on it, so he goes, okay, this contains one of these things, and let it run through there, and then once you get a acceptable confidence interval, which is what they call those things, that's 0 to 1, they give you a double. A double floating, not a floating point, but a double decimal that gives you a confidence interval between 0 and 1, which is basically the percentage of that it believes I see the thing in there, or this thing is what I've been trained to see. And once you get that down, there are ways which I still have to explore that you could download that model to your local box and use that model, so you don't have to go to the cloud to do it. And you should get the same results as you do in the cloud, but you don't have to train it on your Raspberry Pi. But it can certainly run on your Raspberry Pi to get it done.
Yeah.
And I still got to play with that some.
Yeah, I'm trying to avoid a Raspberry Pi if possible, but yes, that's what Harold's talking about is one way. The way this thing works, you got a model inside of the computer or inside the board, and you make images of, say, null, that no, the object's not here, and yes, the object is in here, and then you train it on that, and then ideally, but all of these things, they have a very complex, convoluted model, and then what you're really doing is only adjusting the last few layers, okay? And like I say, from what I've seen, from my donkey car experiences, I'm just, it can definitely do it, but I don't know if it'll be able to do what I want to do. But I want to have actually two things if I can get there. One is the Pixie Cam, which we all know about, and the other one is this Huffy lens, or that's made by DF Robot, I believe. And that one that's kind of cool, and we'll see how that works.
Well, Kelly, it sounds like what you need is to train your Pi up on recognizing that creek and recognizing what water looks like.
Yeah. Well, actually, it was not a problem at all. I did run a Raspberry Pi, and seeing a duck on green water wasn't fairly challenging whenever I switched to just looking at the red spectrum. And then the browns in the duck show up as distinct red colors. So orange cones would be a piece of cake with a raspberry, because you could just look at the red spectrum and the green grass would be nothing, compared to an orange cone. So the image magic libraries on a Raspberry Pi, you can just look at the red spectrum of your images, and that gets rid of all the stuff you don't want to look at, real quick.
And that works in varying light levels and with shadows of trees, with the color and so forth.
I photographed ducks up to about 10 meters away that were swimming in the shade on some green water. I captured them multiple times. And they were pretty small because I have just a normal lens on this rover. So, yeah.
Are these cones going to be placed on grass?
No, they'll be whatever's out there, and I bet in the middle of August it'll probably be brown, whatever it is. And I don't think Steve's going to go out and water his 5 acres, So I suspect it'll really be pretty dead.
Yeah, you might look for any filters available on those cameras, because a red spectrum would be real handy.
Well, it would be nice to find some. I haven't really looked, I guess, but I wonder if there's has anybody seen any 12 millimeter mount filters that you can, put on the end of those things?
Doug, the ones I used, and I had to make an adapter, but you have a 3D printer.
Yeah.
There are filters that are made to go in telescope lenses.
Telescope lenses, okay.
And I have a couple of telescopes and a whole bunch of lenses, and so I had filters for those. Lots of different kinds of filters, and had 2 different neutral density filters. I ended up using the heavier of the 2, and just made a little adapter to fit on the front.
Well, I've got from my old 35 millimeter photo days, I'm sure I've got some, but they're probably 55, 58 millimeter.
Those are probably that.
Yeah. So I don't know. I'd have to see if I could get something like that to work. Yeah. Hey Harold, what's been going? You've been awful quiet today.
Well, most of it's because I was working a little bit here, and I finally got a GPS module so I can see it on my robot. What I did got my going in the stream last Friday was my pan and tilt. I've now plugged that in to the board. I've now fired up, thanks to one of the members of the ExoMy Discord, who's done some work and shared his code out on a fork. I went and grabbed his servo module and servo messaging thing that he kicked in. So I integrated all of that, changed the names. I say to protect the innocent. It's really not innocent. It's just I made different decisions than what this gentleman made on how I wanted to do things.
Mm-hmm.
He's doing more. I'm going to do this so everybody can do it in this generic way. I, at this point, don't really give a whatever. I want the thing to work, and I wasn't going to go change my code. I'd rather just modify his and integrate it into what I've got. I was saying out all of that, and looking through the this drives the robot now. This does the pan and tilt on the for the camera and what's going to be the LiDAR looking at it. So I got that integrated. What I have found out, I've heard several of you complain about I2C in a few ways, and I've got actually comments on a few things that were going on tonight. And I'm seeing some of that I2C. I've not bothered to track it down yet because I want to get everything talking, and then I'll worry about making it. You make it work, then you make it better, sort of thing. And what I'm seeing, I'm happy and sad at the same time. What I'm seeing is my Python nodes are catching an error, which makes me sad. But because of the way Ross has got some stuff constructed, they reset themselves, and within about 3 to 5 seconds, they have rebooted themselves, reinitialized themselves, and are now running again. Okay, so there's some resiliency baked in somehow. I'm not sure exactly how, whether that's just the way they're just going to work. But most programs, when you're running the things, if you catch an error, you just die, right? In this case, it dies, it hangs out for a little bit, and I think the ROS master controller, because this is a ROS 1 setup, finds out it's dead, and I've told it to keep it running somewhere in the configuration file because I've seen that before. It fires it back up, and then I'm able to do it, able to control things for a while. I suspect what's happening in my I2C is because I'm getting a GPIO access error. So I suspect that I'm overdriving the capabilities of the I2C communication. I haven't checked whether it's running at 400 or 100 kilohertz on that, I think it's kilohertz. On the data transfer and that kind of thing, which might have a thing with as well, because basically what I haven't seen this before. I've seen it actually stop with watchdog timers, but somebody else has seen that. Like the robot will come to a complete stop, and you have to just push the stick forward to go forward again. Let it go back to neutral and push forward again. And I don't know what that is. I'm not the only one seeing that. But on when I hooked up my joystick, as I'm moving things around, I'm moving it quite, as Murray says, quite fast. And the pan and tilt are tracking really well with that speed, and until it errors out. So I think I'm overdriving the bandwidth on that. And so he says, "Hey, I'm doing something. Don't ask me to do another thing till I get done doing what the last thing you told me," which I suspect is happening, but I don't know for sure because I don't have enough diagnostic tools to tell quite yet on that. Like I can't tap into the I2C signal and watch it on a node scope, or a logic analyzer because I don't have much upset on it.
Harold, there is one tool that I've played with, which is a hardware. It's like a $50 object. I can't remember what it's called. I'll see if I can find it. But I think it was. I'm trying to think who sells these. But there's one for SPI and one for I2C, and they're a little board you plug in, and you get a little visualizer of all the signals. And they're quite handy. And I'll see if I can maybe into the mailing list because it's in a box somewhere.
Drop them. Nice. I'm all looking forward to that. But I was really happy with all of that. And then just tonight, when you guys were talking, somebody on my Discord channel who jumped onto my stream last night, Monday night, when I was trying to get my GPS now to work and give me real kind of data or some kind of data, then I can go grab the ROS node that knows how to read that right socket to do all the right things. He sent me a couple of links, and I said, well, let's give it a try. I've got nothing better to do. We're talking about Python this, Python that, and ballistic versus servo. And I'm like, okay, let me go bang on this. And yeah, what it turns out to be is I make crap JST connectors. That's what it comes out to be.
Murray, is that device you had shown us once before, or is that something new?
No, I've had these for a while. There's actually one for SPI. I've got both of them. You can actually get them from Adafruit. So if you go onto the Adafruit site and look for I2C driver or SPI driver, they sell them. That's where I got it from.
Okay,
And it's the I2C driver is item number 4267 on Adafruit. And they're like about $50 or whatever. And they're actually really cool. This has got 3 I2C connectors on it. And you plug that into your device, and it monitors the actual signals, and it's quite a nice little display. These are really cool, actually.
4267 is a Scout Makes Robot Kit.
Oh, then search on I2C driver then. I'm actually reinstalling Linux on my desktop right now because I mistakenly got to 2104, the latest version, and it sucks. I'm going back to the 2018 version. So my whole orange screen is purple and orange in my face because I'm actually reinstalling Linux. So I can't help look on a different computer. But yeah, it's the I2C driver from Adafruit. They sell them. They're actually sold by a company that's at I2CDriver.com. So that's the card.
And so Murray, you basically stick that between, you stick that on the I2C bus?
It looks like, yes, you plug, I'm not sure. Well, it's got 3 I2C 4-pin connectors, and what I was doing was, yes, you plug it between. I think that's the power. It's got a USB power connector there. I can't remember actually off the top of my head.
But it's basically going to display the signals as they go by. Does it drive any signals, or just let you?
It displays them only. And it's quite a clever little display. The display itself is actually really handy.
Oh, got it.
And I did want to say one thing. I want to at least apologize to David if he has any idea that I am in any way critical of what he's been doing, or think that he needs to modernize. Whether he does or not, it's up to him. But no, the path that I've taken, David, is on a Raspberry Pi using Python for my own reasons, which I've talked about before. There's no inherent criticism of what you're doing.
Murray, no apology is necessary, although it's appreciated. But heck, if we can't beat the shit out of each other in here, where can we do it?
Fuck your dukes, man.
Oh man, some people might want to refer to this as healthy debate. I mean, because
there you go.
If you can have, here's what I think one of our problems is in society in general is that we're having a great debate over very passionate things that we firmly believe in. You have a firmly held opinion on each one of you, and at the end of the day, no matter how disagreeable you are doing that, you're still buddies and you're still pals, right? And we can still be friends. I think I think as a society, we've lost that ability in general. I think so. So
I've heard that expressed even on our little chat board, where younger people seem to get into fights with each other rather than actually just discussing or even arguing.
Yeah.
So
but I found that thing. It's currently $30.
Ah, okay.
And
cool.
The number I'm looking at, the product number 4267. I don't know if that's what you said before, but that's what it is.
Yeah, it is.
That's what it is. So
cool.
But but back to my thing here. The thing blows up, which is fine. I don't, that's okay. My next step, and I've already checked the I2C pathways because I can see the I2C devices on there to light the LiDAR and the IMU together on this. And I think tomorrow night on my stream, the GPS going in, there's on the Ross thing, seems like there's a half a dozen different modules and messages, and there's a translation that I need to understand, that where you're taking these GPS coordinates and you're translating them into the quintillions, or they've got some terms I've never seen before. That's basically turns them into some standard frame of reference that the raw system likes to use for figuring out, where the robot is and where it's pointed and all those sorts of things. So I get to go through some of that and figure that out. But I mean, it's been pretty cool. I don't know if I'll be ready by August to make this autonomous, but like David has said, I could point the robot in the right direction, turn it on, and say go forward until it runs over the cone, and maybe get a point. So that's going to happen one way or another, and that kind of thing. But I was able to jump into fire up the Ross node, jump in, and have it going. Jump into the container that it's in, and fire in messages, much like Murray is doing with his robot. Except that I'm not pressing a button to do it. I'm actually typing on a command line to fire a message into a topic or into the event system, and have the right thing pick it up and do the right thing with it. Which I was pretty happy about that. So I got that working, or not that I got it working, that I understand how to work it, not that I understand how it works in general. I got a high level concept of how it works, but the lower level things and how messages happen. And the GPU is kind of complicated to do stuff, so I don't know how long that's going to take me to deal with.
Harold, you get lucky. Maybe I told this to you before, but one of our contests in the long time ago, I was the only one that entered the can collecting contest, and Ed Kaufman's son realized that. He went and set his robot down on the floor and just aimed it at a can. That's all it could do. I don't even think he hit the can, but he got second place.
In general, though, because I'm standing on the shoulders of giants, I've learned lots of stuff. I've figured out a few things. I beat my head into the thing, but I've definitely gained lots of knowledge. And as far as this little robot goes, I think I've come to the decision that I want to make it an autonomous, make it kind of a vehicle for testing out some AI sorts of things, and probably not do too many mods to it once I get it there, because I think this is a really neat looking thing. And not that I'm going to be star of the show, I'm not even trying to do that necessarily, but when we go around and do, when we get to go in-person things again, I think it would be a neat addition for show and tell when we do at the thing. And it's going to work really well. And again, it's got plenty of juice to do lots of different things, so I can try out some junk. But I've got some other things that I want to play with as well eventually. But yeah, this is probably going to be the way it is for a long time, unless some part breaks in a crazy way, and I really got to get it. I mean, I'm probably going to reprint. I know I'm going to reprint some parts anyway because I made some modifications to them, and I printed down and dirty some crappy PLA. By the way, inland PLA, just inland PLA plus, not the tough, not any of the other stuff. The normal bottom of the barrel PLA, which used to be really, really good. I got some because it was the only kind that had rainbow, and I wanted to print with some rainbow filaments. I'm just going to chunk that in the trash. Well, I will not buy any more of it. I'll put it that way. Because I do have a roll of marble over here that looks like it's gray with black bits of PLA in it. So it has a marble-like effect when it comes out. And I thought that'd be cool to print some stuff out of. And it may be all right to print out some things that's going to sit on the shelf. But I find this stuff it delaminates really, really easily. It doesn't print very well. but your mileage may vary. That's my mileage. Don't let my mileage be your mileage, you know. But the PLA Plus, which I've got a roll of that, and the Tough PLA, I like the Tough PLA a lot. I think it's printed really well for me.
Well, Doug, I don't know if this would encourage or discourage, but I'm not going to enter the contest in August. So that opens up room for other people and their robots.
I'm not, Dave, it's not going to impact me at all because, like I say, I'm going for 1 point. Actually, I'm going for, what I want to accomplish this time is go to the cone, stop touching the cone. If I get those 3 points, then this one is moved ahead from what I was doing before. And if I go there, I might decide to go further, but right now I'm just trying to get where I can get my end game on the cone straightened out. So, and we'll see how it goes. I'm still using an Ackerman type RC chassis, and so it's not going to be as robust as some of the other ones, I think, but we'll see how it goes.
So, David, you're not going to get your gold star?
You're not going to.
I'll have to get it in another way.
Well, I was really looking for you to get the, the top award with the.
Oh, that'll have to wait till next year.
Okay.
I'm getting ready to go out of town. 3 days I'll be up in Colorado, and building robots will be very, very low on the list.
Yeah. Right behind trout fishing, right?
Trout eating.
Trout eating, okay.
I did have something I was playing with this week, and I'm not really sure. I was hoping Dave Ackley would be here. It's a kind of a Dave Ackley question, but what I was playing with, I'd heard somebody say last week something about they were implementing a PID controller, and they were trying to decide whether or not to implement electric braking. And we'd had long discussions about, various ways you can set up a H-bridge so that it can, you can do regenerative braking and that sort of stuff. Although I don't think anybody had gone as far as to actually charge their batteries with it.
Well, not charge your batteries, but I did put an article up on the web, on the DPRG website about that.
Okay. Well, maybe I should read that before I say anything.
Yeah. Well, go ahead. I mean, what I did there is I set up the 3 different ways that people normally do it. And so the way David was doing it with the braking all the time, it's all laid out on that article. And I will say this, he converted me. I'm using that mode. So.
Well, here's what I was playing with it. And as I say, I may not be ready. I need to think this through more carefully, or maybe even set up a demo.
Mm-hmm.
But it is my belief at this point that a PID controller itself does electric braking. And I'll take you as a thought experiment. You have a heavy robot. It's moving along at 50% full speed, and you decide you want it to slow down. So your speed controller sends it less power.
Mm-hmm.
And is required to run 50% full speed, but because of the weight and the momentum of the robot, let's say we send it at 40%, it doesn't actually slow down that much. It's not actually following exactly. And when you're speeding up, you have the same problem, but when you're slowing down, basically you have sort of this coasting problem. So the PID controller sees that the robot is moving faster than it requested, and so it lowers the output power even more. And for those of you who may have experimented with this, if you pick up your robot when the battery is unplugged and just grab and turn one of the wheels, and you'll see the LEDs on the robot come on. You're using the motor as a little generator there, and that's exactly what's happening here. So eventually, because you're not slowing down, let's imagine you're not just a big heavy robot, but that you're going downhill, so that the robot continues to roll even when the power goes to 0. So the PID controller will now drive the power negative. At this point, the wheels are turning in the opposite direction than they're being driven. And that, by definition, is electric braking. So I think a PID controller itself provides electric braking. And I've got a demo. I tried it out in the hallway outside my office, where I just ran the robot as fast as I could and had it slow down in the shortest distance I could. I don't have any numbers, but subjectively, when you look at it, you can say that robot is braking. It's not coasting to a stop. It's hard braking. And maybe I can video that for a demo. Anyway, I wanted somebody who knows more about these things than I do to comment on that. Kareem, would that be you?
I can comment even though I know less. But yeah, I'll agree with that. So we have our robot is pretty heavy, and when it gets up to a head of steam, it doesn't want to slow down. But when we're doing navigation and we're seeing that we're getting close to a target, and this is using PID for positional control, it will definitely put the motors into reverse in order to slow down. And you'll see it much more dramatically on a really hot, fresh battery. In fact, ours will actually sort of skid backwards as it's trying to stop if it's on a very fresh battery.
This has been my suspicion, so that's great to hear that confirmed.
And is this all just on a regular PID controller?
Yeah, you don't have to do anything different to the PID controller. You've already tuned it. With I think you probably have to have a D-term in there. For it to work this way, but it'll definitely do that. There's another mode that a lot of motor controllers will support that is not the same thing, and that is a braking mode when you basically when you send it a zero command, right, to go to zero power, and some of those will have either coast mode or braking mode. That's a different kind of braking. That's where it's shorting across the motor outputs, and it's not really regenerative. It's not coming through the through active motor control.
Yeah, because I use a Thunderborg, which is a UK controller that has up to 5 amps per channel, so it's a nice big one for the robots I'm doing. And I actually emailed them about a year ago about braking, and he said no, there's no braking at all. But he said it's almost like at the motor controller level, if you say slow down, the thing does its own braking. That there's nothing in the motor controller that's actually for that, but it will inherently brake. So,
I'd like to, Kareem, you don't happen to have a plot of that, do you? I could make one. I'm just lazy. I'd like to see the acceleration should be ramping down, but the power going out of the PID controller should actually go negative.
I don't actually have a saved graph of that. We do live telemetry and live graphing, and we can see it there when we're
so you
doing
have
debugging.
seen, okay.
Yeah.
All I've ever seen is the robot's behavior, and that suggested to me that that's what it was doing.
No, you can definitely see the voltage going backwards.
Cool. I think those RoboClaws that Ray and I have, I've got mine. I have it plugged in a little bit. I think that has provisions to do that braking and maybe some regenerative stuff built into the base kind of unit. I mean, you get them from the little bitty 3 or 4 amps up to the 30 amp or the 60 amp ones. But when I say that, they're not really all that big. But I think they've got some provisions in there for setting that up. It's a pretty capable little board. So I would be surprised if it, because I know for a fact they give you a sample circuit to protect from the voltage spike you get back off the motors as they're coming to a stop, to protect your stuff from getting blown up. They got some diodes and things in there to shut it off into.
Harold, that sounds like that they actually have it set up so that you could actually use that to recharge the batteries, which of course would be ideal.
Yeah, I think it's there, but I haven't read the 100-page manual in a year, so don't quote me on that. But I think they have I think they have it in there to do that. Facility.
That sounds like the lock anti-phase mode. And that's what it sounds like. And that's the one that's going to be the most regenerative. In fact, you got to be careful to make sure your battery can handle it.
Yeah, that was what I do remember that was particularly set up to say, hey, you want to do this to protect, that feedback from coming in and doing something to your battery.
Yeah.
I remember that circuit in my brain. I have that picture of the schematic there, but the details are fuzzy.
Yeah.
That's all I've done this week. It was just a thought experiment.
Well, hey, David, go ahead and read that article and see if that brings any light to it.
Well, I think I did read the article now that you've spoken of it, and basically that's talking about different ways of doing PWM, sign magnitude, locked antiphase, and so forth. And this would be separate and distinct from that. This basically has to do with the PID controller driving the control voltage negative in order to break. So it's just and it would work with any one of those PWM models.
Mm-hmm.
I actually had trouble with the locked antiphase because I thought it drained the batteries really quickly.
Yeah, I don't know. It's, it's essentially everything has got, it's the actual activation of the circuit is actually happening on both sides of the bridge. You know what I mean? You're constantly pushing current one way or the other. Where the other, with the coast, it's only going on one side, and the other side is basically everything's turned off. And then
that also means that when you're sitting still, you have full voltage on both halves of that, and you're trusting that they exactly balance each other out, and that's why there's no current flow. But that really means that you really have a lot of faith in the accuracy and quick switching times and everything of your hardware. In point of fact, I don't think they ever actually exactly line up and balance each other out, and the excess turns into heat, which is what's running my batteries down.
Probably.
That was my conclusion.
Yeah, I wouldn't be surprised. That's the one mode that I personally didn't feel I needed. You know what I mean? But David's method, it basically saves me an input, and it also, I don't, with the most common one where you use the two inputs and have the pulse width modulation on the enable pin, that mode, when you turn everything off and you've got a voltage, that voltage has got to go somewhere. So it's probably going through the protection diodes. You just can't take a motor and shut it off. I mean, it just doesn't work that way. So anyway, I kind of like the method that was self-phase or signature magnitude or something like that. That's the one I'm using now. It works fine, at least on the small motors I'm using. Well, guys, I guess I'm going to have to call it quits. Bye.
So yeah, I think I say about 10:40 in my case. So yeah.
Right. Have a good evening, guys.
Is Carl there? Or well, I guess he'll take care of totally logging off.
Okay.
Or do you want to say
without dragging it out longer?
Murray,
is there
are you
any
still
updates
there?
on Moonday?
Yeah, I'm still here.
All right. I hope I didn't give you too much trouble, my friend.
No. It's all good fun.
I won't see you guys for a couple of weeks, but I'll think of you while I've got my feet in a cool stream in the Colorado Rockies.
Oh.
So you're not going to fish, you're just going to go to the place to buy the fish that's pre-cooked. Enjoy it.
Yes, sir.